What happened to my internet? Wow. All right, let's continue. Hello, Botrix. Welcome back. Where is my okay, this is the one. Don't dump everything thing at once and make, make sure that you don't complicate things. Let's learn the tan stack and other things. Cache invalidation. Cache invalidation front end. Error boundary is good. I don't know. React memo, use transitions. I never use them. Like use default value. No idea. Testing basics and widest RTL concepts, not syntax drilling. XXX, XSS standardization and hot flow in the build tooling basics. Build tooling. Total 7.5 hours with breaks and doable in a day. If you don't rabbit hole, it's rabbit hole. What does rabbit hole means? Rabbit hole means complex, time-consuming topics, distraction that pulls you deeper, deeper away from the original plan. Oh, you mean like doom scrolling in terms of studying? So what we are going to revise is like first we are going to check the lazy loading and other stuff, how to optimize the React app, and the next one would be going along with the revision of hooks and then we can learn the tan stack query. I guess more than enough. I guess after that we can check something about the error boundaries here. So I think that should be more than enough for us to learn those things. So let's start. For now we can pick the topics and just move in. Like we are not going to cover the basics, like we have the JSX and we have props and we have composition and control form, which is like forms, creation of forms. You might be knowing that thing. If you are doing React, then and use effects, you know them. Like we can revise this use memo, use callback, and use context. I think use context is for context creation, like context API. We don't need to revise that. Custom hooks, this is defined by our own. Like we don't have to deep dive in that much, I guess. So we can skip the fundamental for now since we already know a bit about the fundamentals. We can look into the real part where React Router DOM. Um, I know how to create the basics of routings, but I never deep dived into the nested routing. I guess like we have some protected route and inside that we have some other validation and stuff. Maybe we can look at that thing. For now, we have to uh, start with the tan stack query. So let's go. We'll start with the tan stack query, and in the end, should we revise this or like should we? Let's first revise this first. Uh, the built-in React hooks, we are the hooks are nothing but just a special function in React to perform some operations, I guess. Like, and the state hook is used to store the state of the things you have in your current component. uh, why you need a state? You need a state so the React can know like where the mutation is happening and can re-render it on the DOM. Okay, like virtual DOM. The real DOM wherever. How do I say that? Imagine, just imagine. Don't think like I'm saying something out of it. Like just imagine this is going to be the real DOM and this is going to be virtual DOM. So it is going to see what are the things have been mutated in the virtual real DOM, and it is going to copy change according to that in the virtual DOM. So that's how we are going to learn that. Use state declares the state variables that can update directly and use reducer. So all these are about context API or what? Like I'm able to see the context API right now. So I think we have a lot of books here, but we are not going to cover everything. We are just going to cover what is needed for us to be working somewhere. What is use action state? I never see it in this state. Yeah, thanks, buddy. Thanks for dropping in. What is use action state? Oh, bro, this is so much complicating. Like, what the hell is this? A function is called when an action is triggered. When called, it receives a previous state initially and provides you to the previous return value. Its first argument followed by the action payload passed to the dispatch action. Initial state. The value of state is to be initial. React ignores the argument after the dispatch action is invoked for the first time. Optional permalink. What is permalink? A string containing unique page URL that is the form modifies. Um, so it's gonna persist my state or what? Like we have the user for that thing. Why do we need the use action state now? The dispatch action function that you call inside actions, the is pending flag tells you that if any dispatch action for this hooks up pending. I have no damn idea about this shit, bro. Like, what is this scab waits? I never ever heard about this hook in React. Caveat is a warning condition limitation explains. I'm getting inside the rabbit hole again. I think I'm getting inside the rabbit hole. What the Claude said to me. Don't get inside the rabbit hole. We don't have to get inside the rabbit hole. Let's focus on the topic. Uh, Even though I need to know the meaning before I learn something else. This, let's see what are the things we have first. I think all these are used for Next.js, I guess, like use client and use server and shits. Why do we have this in directives in the React? Oh, what is purity? Let me focus on what we need, man. Like I'm not gonna deep dive too much inside this thing, taking the whole like it will take more than a day to do this thing, I guess. But we are gonna focus on the main important part, and you can just move to the next part. Then we have some use transition, like all these are used for animations or stuff. So strict mode is used to check if it is working fine or not. Like we have in the main component. What is use sync external store? Wow. Okay, let's. We already know the use state, so let us do the use state. I'm gonna remove the node module so I can save some space. I guess I don't have much space on my hard disk, and I think after that I'm going to remove the node modules as well here. And we have the React with us. We can just do some cleanup, which is going to be like this part. And I'm going to do in app.js, I'm going to. Why the arrows are not visible here? Like, why my closing brackets are not visible? The closing arrows are missing. Do you please add it and also disable the copilot? Yeah, also disable the copilot stuff. Disable the copilot, bro. Where the fuck is the arrow then? Like, already have it? Shit. I can't write it this way. Should I write it without a bracket? Remove all and this edit. Yes, editor dot. What is happening? Did we make the copilot? Um, it's not disabled yet. Don't do anything. Don't do anything. Yeah, man. I think now it's disabled because. Yep. Oh, we have the folding arrows now. Now I think it's fine. It's- We don't even have any styles. Like from where the hell is my style is coming? In the index CSS, I have removed the style. In the R CSS, I have removed the style, but I still have this style. It should be empty canvas right now. It should be black. I mean the white one. Why is this? Because of the colors here. What if I remove this? I don't even have anything, man. What the fuck? No way, bro. Why do I have the decrypt and other stuff outside right? Yeah, but in the index file, we did not even have anything, but still it was doing something like what the fuck? Now we have it. We took it back. It should be white. Uh, what was that? Sizing. Yeah, bottom box. 0, 0. I think it is good enough. Yeah, I got it. For FCE, yeah, you have the state. Got the counter example for now. Jeez. The use callback hook allow you to memorize a function so that it's only recreated when its dependency change. What kind of memorize as a function? This is what the use effect is doing. When prevent the unnecessary re-renders, or like you can use the use ref because we actually work with the data. As far I remember, they made to create something called as context, I guess. Way I can create count.js for now. Should it be JSX or JS? I have no idea. Import create context. Ah, it's working, I guess. How do we? Is this that's it? How do you use the create context? Will it be a function? Or like, will it be a component? Use a create context. It's not going to be a component. It's going to be a function, some sort of call the create context out outside of any components and create context. If I have to create the value, we have a light here. As far I remember, will it be like this? try this. It happened. I don't think I can use the use state outside of my component. This is gonna throw me a fucking error. So it will yeah, you can't use it like that. How did I actually create it then? Why the fuck I don't even remember that thing? Oh, okay. Because you have to create a context and you have to create the provider. Right. Yeah, we have to use it. Use context directly. Let's use in the state.js. I think we need to improve the use context again. Use it count. We use it. We use the name of it. I only have Maybe here. We had ruled in that thing. We are getting some issues. What? You mean everything should be JSX? This is how we pass the value, right? Oh, what do you mean by array? It should be J. Yo, this is fucking great. You're complaining for every shit. Yeah, this is not JSX. This would be having this shit. Okay. I don't have that thing, man. Like, what the fuck? Ninth line. I don't have anything. What are you trying to say right now? I mean, using this thing, using passing the value. Maybe. What it is this on here. Like, on create context. Provider has been created here. Once provider. Is it because of input errors? This is why I hate front end. Even this thing. So, for real, was that the error? Let me do this. Pass it like this. Uh-huh. So can I use it? This states. How to use it? In the use context, I'm not able to pass the name. Oh, we have to use it like this. We have everything in the use thing, like create a custom hook for every issue consumption. How to create a use for them? Should it be use decrement or it just create a custom hook for easy construction? When he's returning the use context, it's a bit shit. But we ain't even doing that thing, like we're doing something different. It shouldn't be that case. Didn't export it. Okay, we're not facing any issues. I think we are good to go. Okay. Okay, we are facing some issues. It says JSX. What the fuck? Is my syntax wrong? It's saying something different. This mother. added JSX. You told me to make it JS, and you're asking me to create it. Ah, did we get what we wanted? I don't think. There are some bugs. Small letter is not supposed to be a component. It won't work. And what the fuck is this? Fast refresh only works when a file only exports component. What the hell is this guy asking me? What is this? Bro, well, fuck you, man. I'm not using TypeScript. What the fuck I'm saying? But what? Thing here? There are some import error. Like, do you have something called as name? Does not provide name export? The fuck I say? I'm providing it. But now I understand. It should be capital C since this is going to be JSA component. We're considering as a component. Still not working. But there are no error here. Like, what the fuck is wrong with you then? The hell? Bro, this is why I hate front end, man. Like, what the fuck, bro? There are no errors shown there. Here and but here I'm getting a fucking error. Did you? I think it worked this time. But where are the content? Oh, why do you have a black screen? Do I have the content or not? What the fuck? Click on the problem tab. Where is problem tab? I don't have any error now. Why the fuck? Nothing is visible now. Maybe I will go with the normal mode, bro. Like, of this. Now I understood. But I have a name for them. Like, what the fuck? He is still not working. No way. What is happening with me right now? Context API is driving me so much crazy, right? Uh, what do you mean by count.js is not? Oh, no, I have it. Saying like we can't export two things at a time. That shouldn't be a problem. Exporting this is not working. It's some nasty stuff. I don't think this will also work. I'm using a default export now. What the fuck? No way. React is driving me crazy, man. Like, what the hell? Then this is not working. Even my normal export was not working. What is happening right now? Count context blow. If I make it JS, then I won't be able to use these things here. But if I make it JSX, I'm not able to export this shit. Like, what? Should I use a named export? Click on the problem tab in VS Code use. Problem tab. What is this? Fast refresh only works when and file only exports components. Move your React context to the separate file. You may have to create. Oh, you may have to create this thing in a different file. Bro, are you kidding me? I don't have the access to the control. What is that? Create context. Why, why there is no suggestions? Bring the create context. If we get it, does not provide a default. What? You want the you said right? You said define but never read. What the fuck? I'm using the fucking use there. You mean here? I'm not using it. React. Now we don't even have any error right now. See, there are no problem here. Like, what the fuck, bro? Now it's working. What the heck? No way. So the problem was I was trying to do both the context and the provider inside the same thing. Shit. Yo, Tejas, welcome, man. We got what we wanted. I think we can install the tailwind as. What was that? Oh, white, yeah, white. I never used the problem tab in my life, bro. Like first time I'm using the problem tab. Thanks, buddy. Did it install or what? It's installing. Install the React Native full pack extension to the VS Code published by Kelsey. Select. It gives suggestions. React Native Select. You mean this one? But this is for React Native. I have the ES7. Trying to do the context API. I mean, like the context and the context provided in the same file branch. I think it's fine. We can debug from the problem tab. Not an issue. I'm not able to find it. Let us style this a bit. I even remember the styling. Why the background is not turning black? My CSS is not working. Yeah, my CSS is not working. Why? Oh, why these problems are arising? Like, what the hell it is coming? Tailwind, I have the tailwind imported here. I don't even run my front end. It's working. Anything. This looks good. So we have to take a box and we need two buttons, smaller buttons below it. And get the same shit. Why text is not coming in the center? Okay, we have it. Button and okay, outer one is thick. White. Right. The text is like not yellow. It's black. But let's remove the amber. Yeah, I have something. Like UI. UI. And let's remove this time. Is this the color? Closer enough, I guess. Closer enough. Wait. We I think that if you don't know how to design something, just copy someone's design. We'll be good to go, man. I think there is too much space in between. I guess I can find. Yeah, not the exact one, but yeah, looks closer enough, I guess. Like we need to give some space below. 10 is too much, I guess. 7, even the height is too much bigger for this shade. Like 250, I think. Close enough. Yeah, close enough. It has a fucking shard. Let's remove the BG thing right now. Just going to be this. I'm going to make this thing as gray. 300. Maybe white with 50 percentage. Now we're able to see the shadows. You can add the shadows to this. Yeah, looks good. Not the best front end design, but yeah, it works fine. But when we don't know how to design things, we have to copy the design. Thanks, man. Thanks a lot. Let's design something else for now. Like let's test how much front end we actually know. Can we replicate something out of awards website or something with the tailwind and his whatever React features? This looks sick, bro. How the fuck is this bento? Okay. Wait. Let's try to replicate different types of counter styles, right? Let me try this. Oh, you have a lot of counter style. Can we try this? How much time will it take to do this thing? It looks like everything is on top of one. We just replicated this one. All this does not even seems to be like a counter app. I'm looking for some good UI design so I can put my practice over there. Like this is getting multiple times popped up, so you can try to do this thing. Maybe I will try to do that. What I'm going to do is like I'm going to take this whole thing and copy it and comment this. How much time will it take to build that thing again? Like, where the fuck it is? What the fuck is this? Oh my god. Yeah, dragging thing is going to be a bit complicated. How do we do that? Shit. I can do the plus one, but I don't know how to do the drag. Everything is going to be black, right? So let us keep the gray thing. Maybe this color, I guess. Than that, this color. 900 is supposed to be black, pure black. Okay, not black. That does not even look like that color. 800 maybe. Uh, Not even close. 700. What is that color? Yes, maybe we can go with the 900 for now. Maybe the styling from here. We have the buttons and we have all the things. Now we have to make it everything center. Yeah, we have a round. The text is only visible. This is not supposed to be this dark. I don't know how to do a drag one, but I will try. How do you even drag the thing? And why one button is having the style? Okay. Now I think it's time to give the width. This is going to be width of SM. SM is too big. 200 is also big. 150 maybe. Yeah. And instead of center, justify between. My text will be like 2XL. Even this will be like 2XL. Text gray 200. Much 400. Yeah. Quite quite similar, I guess. Should it be 4XL? I want to make it big. Make it more and make it more big. You know, make it more big. We got what we needed, but this should be in the round, right? This is way bigger than I expected it to be, and it's not BG. This thing should be BG. More I drag this? How do I make it draggable? Do we have it draggable? Have any options of drag? I don't have drag, drop. It's way more bigger and it's too close enough to each other. Like, not too much far. Space between. Hmm. This is not opaque, I guess. This is supposed to be like bit transparent. Like I can give 70 percentage more, more height, I guess. 20, 80%. This circle is even more bigger. It should be 6. It should be 6. 6. Text center should be bringing the text center, right? Margin auto. Next auto. The element is coming in the center, but the text is not going in the center. Right? Let's give PT 10. Let's say PT 10. Still looks so smaller to me. What the fuck? I'm gonna make it 600 now. Fuck this. 600 is too big. 400 maybe. 400 is also big. 300. 300 looks sweet spot. Center, but with some space. Why center didn't go? Center, justify content center. Should be center now. What the heck is this? Maybe because of V3. Uh, is this? Coordinate center, justify content center, MX auto. What is wrong? What is wrong? What is wrong? What is wrong? They should be doing the thing, bro. What the fuck? It's not happening. Nice. Center thing is not working. Like And undrag. Okay. Undrag, you're going to call decrement, man. That's it, bro. To drag you. I'm able to drag you, but why the value went so fucking fast? I'm not able to drag him. I should select you for dragging. And why the fuck are you not moving from here? Like, this guy's moving here. Ooh, okay, my circle should be draggable. How do I check if it is closer to my minus and maybe we can get some distance or something. On-draggable if I call, on-draggable if I call that thing as an, maybe you can do one thing. Maybe take the position of this plus and minus, and whenever the circle goes near that thing, we can reduce or increase the value. This center thing is not working. What the fuck is wrong? Here I put something wrong here. Flex row gap two. Is it because of gap two? Gap two doesn't matter. Don't tell me it's because of gap two. Ah, my styles are not even getting reflected. If I type something here, it's working. But when I'm trying to assign everything in a justify content center, justify center, I'm not getting suggestions. Why it's not becoming center now? Okay. Did this one take a lot of space? It only took PT3, which is very bit from top inside the component. But my justify center is supposed to bring everything closer enough, but this motherfucker is not even working. No idea, man. Let's ask here. MX Auto on the PX is pushing the button for 300. So what do you want me to do? Decrement usually provides better spec. MX Auto from P. This one. Huh? Yeah, I already did that thing with the PT3. Then why did I even put it again? It's the position of the plus and minus sign. We can make the PS draggable. If I do on draggable, if I call increment, then it's working, but it's going to be increment every time. So we have to see if my draggable X position is close to the plus or Y position is close to this. That's how this guy is doing, right? Or he's doing something different. Maybe his UI is looking good. I don't know what the fuck is this color like. 500 or 300. 500. 530 percentage. 540 percentage. It's not even close. Is this pure black? I don't think. You can make it 60 maybe. 60, you get the color, I guess. Yeah, we got the color of that thing, but what about this color? I think we got the color. But 700, not in 700, 70 percentage. Too bright. Wait a minute, bro. Wait a minute. How do you use this color? Should it be like this? Can I use it like this? Should it be like this? Yeah, it was. Yes. I didn't get the same color. What the fuck I see. Maybe I have to look at the image instead of the video. I think now it should be able to pick the color. What the fuck is this, bro? Think what the you got the color. Is this the color? No, this is not the color. Ah, fuck the color, man. Let's try to do this thing. If I'm doing this drag, then it is working, but I can't drag the element itself. Yeah, but after drag, it shouldn't be showing this border and bullshit. While I'm at the plus, then it should be here and it should. I need to get the position of minus on it. Can we track like we are dragging in the left or right, like something like that? If we are dragging in the right side, then we are going to increase. Let's say decrease. Let's ask the AI, like, can you track that way? Last x is 0, then it is going to be center. If it is greater than this, moving right. This thing. Shit. What kind of idea is this? This is crazy. Set the left and right direction, but yeah, you get the idea. don't have any property called index. I think it's supposed to give me the property of maybe we can take. Well equals to 0, then reset position. If e dot line dot x is greater than my last position, then it's you can take direction, I guess. On it, I think I don't even need the direction now since I'm not directly calling the function itself. That is true. Then how are we going to do this? Like handle drag, on drag, handle drag. On drag is supposed to be handle drag. Then what on dragging? Do we have anything called as on dragging? I think it should be on drag capture. Let's try. See, the decrement is working, but when I'm keeping it here, it's not. Even for this, like, it's not constantly doing that thing. I'm not able to move the. I'm not able to move the whole div. I was supposed to move the whole div itself. Crazy. I think I inverted the logic, lol. If it is right, then it should be decrement. And I don't want the thing to be escaping from there. Right? Again, I did the same. No, now it's fine. But it's going out of the box right now, which shouldn't be possible. Like this guy is having something different, right? It's not escaping that thing. Like it's what do you call this thing? Illegally shaking thing. Whenever we are doing this thing, then this thing should be moving from here, like for for an instance, and then if I leave, then it should be rolling back like a spring. This is working, but when I try to do this thing, even here also it's working. Like when I do this time, On the right side is increasing, and it can't go beyond nothing, I guess. If you're moving slowly, then I think you can go till I guess. Let's go from here. I think it can go till how. If you're moving slowly, but if you move faster, then see, it can't get much value. But if I move too slow, like this, I think now you're going to reach 1000. Okay, it stopped recognizing since you are not moving in the right direction anymore. But if I move in the left again, like it will start reducing. This is fine, but it should be inside the table. How do you do that? So we had we got the help from the AI, like how to get the client X position and can check if it is increasing or decreasing. It shouldn't escape that thing. How do you lock that thing inside the table? Yeah, if e dot client X um, we have a width of 300 pixels. Maybe you can return, I guess. It should work. So this is more than 300. It's returning. Now it's not updating, but I'm still able to drag it outside. It should be only till here. How do you set the limit? Framer motion, I'm not willing to use the framer motion for now. To do that maximum, yeah, I try to do this like instead of storing the maximum, I directly did. Oh, I have to set every mouse events. Wait a minute. I have this for now. I think I'm making mistake in the very context. Do not the visual drive. I want to prevent it, man. Yeah, yeah, bro. Yeah. Let me try this. Ooh. Transform translate. Oh. Yo, what's up, Giri bro? Just revising some React concepts and trying to do some CSS to get back the old good guy in me. Sorry, man. You didn't go to the office today? Is it Sunday today? Oh, it's Wednesday. Yesterday I could not even stream, bro. Like I had stomach pain. Let me try use memo and other stuffs. I never much used them. I guess input try. Use layout hook is similar to the use effect, but it's executed synchronously after all DOM mutations. This make it useful for the manipulating. Let me. How do we write the private route first? Like, will it be an API call to the backend and checking if everything is fine, or like will it be something different? Private route, yeah, okay, is authenticated. Fine, man, as expected. So what about the just one more thing? Error boundaries, I guess. Might come from the APIs and the UI from several other places. It's important to handle these errors gracefully and maintain the good UX despite of the error. Error boundary is one of the such way of error handling in the React. How does the error boundary helps to understand and let me check if there is any chat. Before error boundaries and components eventually propagated and broke the UI rendering the white screen. This was the really bad UX. Error boundary help us to handle this such errors, display fallback UI instead of breaking the UI showing the white screen. How to use error boundaries in React V16 officially introduced error boundary. It's a class-based component which can be wrapped in your application. It accepts a fallback UI to display in case of your application has errors. Otherwise, it can simply render the child component to resume the normal flow of your application. How do I use it though? Oh, if you directly use it, fallback will be like something we want the user to see when our server is shutting down, and otherwise we are going to show the different components. Will it be in the main app file, or like will it be in the main or like in the app.dss? Okay, then directly input this. Any other bound? 'There's nothing called. We have to create it now. Let me see in video how to use the error. Other things doesn't have much. 7 years ago, on the latest. I have to install it.
Using the React Error Boundary package. To get us started, I've set up a very simple application. In the components folder, we have two components, person.js and clickCounter.js. The person component accepts a person prop, and we render the person's first name and last name in uppercase. The click counter, as the name indicates, tracks the number of times the button is clicked. Both these components are included in app.js. The person prop is also passed in with Bruce Wayne as first and last name. If we run this application, we see hello Bruce Wayne and the click counter working as expected. And we know that everything doesn't go as planned when writing applications. Let's assume that we are fetching a person data from an API and passing it into the person component. Only this time, we didn't account for the person data object to be empty. So back in VS Code, let's make a copy of this person component but this time pass in an empty object as the person prop. And this is a pretty common scenario where we as the developers tend to write code with only the positive scenarios in mind. If we now save the file and take a look at the browser, we see an error and our app is broken. And this, of course, is for development. If you were to run the application in production, you would see a white screen with absolutely nothing. So if I dismiss the error, this is what you would see in production. And you might agree that a white screen isn't the best feedback to the user of our broken application state. What would be nice is if we could capture the error and render a fallback UI. The React team made that possible in version 16 with the introduction of error boundaries. Now I am going to quickly implement an error boundary for the app we have, but if you want a detailed explanation, I'm going to leave a link to my video on error boundaries from the React tutorial series. Make sure to check that out. Alright, in the components folder, I'm going to create a new file called errorboundary.js. Within the file, we define our error boundary. So at the top, import component from React. Now, an error boundary has to be a class component and hence the import. For our component code, export class error boundary extends component, and within the class we specify a constructor. This accepts props. We call super, passing in props, and we declare a state variable. So this dot state, and the property is has error, and initially it is set to false. Now for this component to be an error boundary, we need to implement either get derived state from error lifecycle method or component did catch lifecycle method. Let's implement both. So static get derived state from error receives error as an argument, and within the function body we return state where has error is now true. So this basically indicates there is an error in our application. We can also define component did catch, which receives error and error info as its arguments. And in this lifecycle method, you basically send your error information to a logging service. For now, I'm going to simply log it to the console. So logging the error, passing in the arguments received. Finally, in the render function, we're going to check if there is an error. So this dot state dot has error. We're going to return an h1 tag that says something went wrong. If not, we're going to simply return the children props. Return this dot props dot children. So this is our error boundary. Now, if there is something that you couldn't quite understand, again, please refer to the video from my React tutorial series. This, of course, should be render. All right, now that we have the error boundary, back in app.js, we can now wrap our components with the error boundary. Make sure to import it at the top. If we now go back to the browser, refresh, and close the overlay, you can see that the user would get to know that something went wrong. Now the UI could be a well thought out feedback screen from where the user can go back to the home page, but this h1 tag serves the purpose for now. So this is great. We are now able to render a fallback screen when there is an error when rendering a component in our application. All thanks to the error boundary component. Let's go back to VS Code.
Are you tired of wrestling with complex state management and constant refetching in your React apps? Well, get ready for a game changer. In this tutorial, we'll explore 10-stack React Query, the ultimate tool for effortless data fetching, caching, and real-time updates. Say goodbye to clunky code and hello to lightning-fast UI. Trust me, once you see how React Query works, you'll never want to go back. Ready to level up your React projects? Let's dive in. Okay everyone, so now let's get started. As you can see, I already have over here a project that I set up just running npx create feed, but this could work with any other method you want to generate your React application. My project is completely empty, I haven't made any changes, and we want to start by installing the 10-stack query library. So I'm going to come over here, open up a terminal, and I'm going to run npm install at 10stack /react query. As that is installing, when you generate a React query application, when you're creating one, you want to go to the entry point of your app, may it be the main.jsx or the app.jsx, wherever you want, but it has to be the higher point, and you want to define what is known as your query client. Now this is going to be where you're defining the instance of React Query in your project and where you want to also wrap around the React Query provider so that your project has actual access to the library. So you want to do that on the highest level of your project so that your entire project has access to React Query. But you could indeed, if you want only a part of your project to have access to it, do it there and pass the provider to that specific group of components. But in our case over here, we want our entire project to have access to it, so we just want to come to the main.jsx, and I'm going to import at the top from at 10-stack query or React Query, and I want to import the query client and the query provider, or the query client provider. Then down here, I want to create a variable called client, and I'm going to set it equal to new query client. Perfect. Now, to actually enable React Query inside of our project, all we have to do is wrap our app component, which is the entry point of our app, with the query client provider. And then just pass the client as part of props to that component. So I'm just going to copy this and paste it over here. Perfect. Now that means that anywhere in our app, like, we're going to have access to the different hooks and functions that the library provides for us. And now that we have that set up, let's start with some simple data fetching. For this tutorial, we're going to be using over here a public API that I like to use in my videos. It's the JSON placeholder API. And if you go to this URL over here, you should get data or a list of objects that represent fake data for posts. So if you want to do that, you could do that. They also have it for, I believe, users. If I grab this and I put it over here, we should see data for users. Actually, I might do it for users instead of posts. However, it seems like there's very little amount of users, so let's just use posts as an example for this tutorial. So how do we actually set up a system where in our component over here, we're going to have a component where we're going to be able to fetch data from this API using React Query? Well, the most simplest way to do this is to use the useQuery hook from 10-stack query. So I'm going to come over here and I'm going to import from at 10-stack React Query, and I want to import the useQuery hook. So in the simplest form, if you're working with React Query, there's two hooks that you need to get used to: the useQuery
And stack is not.
And the use mutation. We're gonna get to the use mutation. However, we're import from able to, as an example, seem for you, everyone of your is not convert of props to that component. So I'm just gonna copy this and paste it over here. Perfect. Now that means that anywhere in our app, like we're gonna have access to the different hooks and functions that the library provides for us. And now that we have that set up, let's start with some simple data fetching. For this tutorial, we're going to be using over here a public API that I like to use in my videos. It's the JSON placeholder API. And if you go to this URL over here, you should get data or a list of objects that represent fake data for posts. So if you want to do that, you could do that. They also have it for, I believe, users. If I grab this and I put it over here, we should see data for users. Actually, I might do it for users instead of posts. However, it seems like there's very little amount of users, so let's just use posts as an example for this tutorial. So how do we actually set up a system where in our component over here, we're gonna have a component where we're going
And that we don't have anything for the dance stack. Don't do.
to be able to fetch data from this API using React Query. Well, the most simplest way to do this is to use the useQuery hook from 10stack Query. So I'm gonna come over here and I'm going to import from add 10stack React Query, and I want to import the useQuery hook. So in the simplest form, if you're working with React Query, there's two hooks that you need to get used to, the useQuery and the use mutation. We're going to get to the use mutation, however, we're not going to actually use it in this component, but the useQuery hook, like the name suggests, it is used for queries. So for example, for fetching data from an API. And that's exactly what we want to do here. So in order for us to use this hook, we need to come over here and call the useQuery hook. Now the hook requires us to pass in two pieces of information. The first one is a list of query keys which are going to help us distinguish each of our queries by some sort of ID. And this ID will help us whenever we're dealing with things such as cache or just helping identifying this query. If somewhere else in our project, for example, we might want to refetch this data or retry this query, we can utilize certain functions that are provided by React Query and just pass in the query key for this query, and that will actually execute. So it is important that you make them distinct. So in our case over here, I'm going to be passing in a query key called posts, which is going to represent the query for us fetching data related to posts. Now, the second thing we need to pass is a function which I'm going to create, which is going to fetch the data and return back. Now, if you have never worked with React Query in the past, you might be a bit confused because a lot of people have a misconception that React Query is a fetching library like an alternative for Axios or the Fetch API. However, this is not the case at all. It handles all of the complex stuff that happens after you get the data. So things like the loading state, the error state, caching, synchronizing your data, all that kind of stuff is what React Query is good for. So to get there, you actually need to fetch the data. So somewhere inside of here, I'm going to create this function, which is going to fetch the posts, and it's going to return back the data that we're going to pass to React Query. So inside of here, let's just do a simple const response equals to await, and we're going to fetch the data from this API over here, and we're just going to pass it over here. Then when we get this back, if response dot okay, so if not okay, so if there's any errors, then we just want to probably throw a new error saying error fetching data. But if the response was okay, then we want to return the response.json. Let me just fix this. Return the response.json. Perfect. Now that we pass this, we have successfully created our query, and we can now access all of the amazing stuff that React Query gives to us from this hook. For example, to get the data that we want to display in this component, we can just destructure the property called data. Now what this will do is I could now come over here and, for example, loop through the data, grab each post, and as an example here, let's just create a little thing that shows the title of the post. So post.title. We should see that now over here, if I actually go to the root page, and you should see that there's actually an error. And I purposely left this error because a lot of people watching this video might be watching this video because they're getting this error over here, saying that bad argument type starting with v5, only object form is allowed when calling a query related functions. What this is just that React Query updated. So the way we actually use the use query, we have to return an object here and specify that this is the query key and this is the query function. And also we should probably pass in over here a question mark just so that we deal with the data being null before we actually set up the errors and the loading state. We'll do this in a second, but as you can see, we successfully fetched our data and it's displaying here in the screen. Now, if we don't use this question mark over here, there's a couple things that we could actually do to allow this to still work and not fail, because it's failing because for a brief second the data is not fetched, so this data thing over here is null. So what we could do is we can handle the loading state and the state in which an error occurs. So let's go to the loading phase. I'll come over here and this structure is loading, and let's also destructure error. So for the loading phase, I'm just gonna ask if is loading is equal to true. Then we can return a little p tag that is gonna say loading and 3 dots. You'll see that now that doesn't actually error because for a brief second it will show the loading state, but it's pretty fast, so it doesn't actually you can't really see it. But that's how it works. Now let's go for if error then return the p tag with the message saying error occurred, then some message showing the actual error. Now we won't see that because no error is occurring. However, if I want to, I could just test this out. Whenever an error is thrown, you'll see that this happens. So I'm gonna refresh this, it's gonna load. We're gonna see over here, oh, we never returned that. So return new error. However, we could test the case in which this error is thrown by removing this and making it such that if the response is okay, then it will throw it. And you see that it will load data for a bit, and then eventually it's going to fail and it's going to throw this error. Yeah, as you can see, it says error occurred, and then the error message over here is the one thrown. Now, this is an overview of the simplest use case for React Query, which is just fetching data in a component. Now, if you are the kind of person who usually fetches your data by creating a use effect and then managing the data through local states, you should know that this is way better. And the reason for it is because, first of all, the use effect was never created with the intention of being what you use to fetch data. Second of all, you can do a lot more by using this hook whilst also not having to deal with all of the logic and the states for the loading state, the error state, and the data state. It is all generated for you automatically. It makes your component a lot dumber, which is a good thing because it will help you have an easier time testing and debugging your application. Now, one also good thing that happens with the useQuery hook is that TensTagQuery automatically caches the responses of whenever you fetch data. So by default, if you're revisiting the component, it will show you the cache data instead, while optionally refetching in the background. So technically, if we were to not have this component being displayed, right? We were in a situation where we had two different components, and you unmount one of the component, and then you mount the other component. When you actually come back to this component, you have the option to just use the cached data so that you don't have to make unnecessary network requests. So let's see an example of what this means. Okay, so to demonstrate this, I changed a bit our code over here. I moved all of the code that we had before into this posts component. So it's the same thing, but in the posts component. But what I did is, in our app component, I created this state that all it does is it mounts and it unmounts the component. So as I click on this button, it will show the component. And when I click it off, it will stop showing the component. If I click again, it will show again. Now, why did I do this? Because I'm going to explain caching in React Query for you guys and how useful it is. As you can see over here, every time I mount the component, it fetches posts. And then I unmount it, and when I mount it again, it fetches again. So it does two network requests, and it can do it infinitely. And the problem with that is that sometimes you don't need to do that many network requests because the data won't technically change that fast, right? So what you can do is a lot of different things. One of the specific things that you can do is set up what is known as the stale time of this query. So like I said, React Query will cache all of the response, and you can specifically tweak when the data will actually become stale and trigger a refetch by using the stale time property in the query. So if I put here, for example, 5 seconds. 5 seconds, it will have to be represented in milliseconds, so 5,000. Now what I'm saying here to the useQuery hook is that I want the data to stay completely fresh for 5 seconds before it refetches to see new data. So if I come over here and I toggle it once, it will show. But if I toggle it anytime in between 5 seconds, it won't refetch again. When 5 seconds passes, it will actually fetch for new data, because now the stale time is over and it knows that it should be enough for us to fetch data again. So depending on what your query necessitates, so if your query probably changes data faster, you can actually make this into 2 seconds, but most times it won't be like that. Most times you can do something like 10 seconds where it will literally only fetch once, and for the next 10 seconds it won't fetch again. So this is the most basic explanation I can give for caching. I know a lot of people get confused with it, but specifically with React Query and the useQuery hook, it's really useful because of this. Now that we understand what caching is, what other types of queries can we make in our application? So for example, there's different types of queries that we might want. An example that I can think of is whenever we want to pass parameters, like fetching some sort of data by ID. This is a very common use case. So let's actually create a new component. I'm just gonna actually duplicate this. Let's say post by ID, and inside of here, I'll also change this to post by ID. And inside of here, we don't want to display all of the posts. We only want to show one post depending on what prop we pass here as the ID. So how do we do this? Well, we're going to change this use query hook over here to have only one single different thing. Now, the difference is that over here at the top, or wherever we call this function, we probably want to have the ID passed here, and then have the ID also passed inside of here. So for this API, we can just do it like this. We pass the ID here, and this will fetch one single post. Now in our query, our fetch posts over here, we have to pass the ID inside of it because now we have that as an argument. And the one major difference is that in our query key, we want to integrate the ID for this specific query as part of the query key for this use query. So I can change this by adding the ID here. And now we know that if we were fetching this data in a loop and fetching multiple items by their ID, the ID that we pass in the query key will make it such that the query key is completely unique. So let's just test this out. Actually, let's show this over here. I'll actually display. Actually, I'll just display one. To be honest, I'll say post by ID, and I'll why haven't I imported this? I'll just do like this: post by ID, and then post by ID as well. Oh, I just noticed it's all called posts by ID, not post. Now, there's also one thing we want to put, which is the ID over here. Let's make it such that it will fetch the post with ID 3. Also, there's two things that I want to change here. I don't want to display the data. I want to display, I'm not going to map through the data because the data is going to be a single post. So actually, I just want to display the data.title. It's just going to be one single post. Now, it's still giving us an error. And the error is because this fetch posts over here, when you're passing the ID as an argument to it, this is not actually being represented as a function. What this is doing is assigning whatever this returns to the query function, which is not what we want. We want to set a query function to the query function. So whenever you're passing this, it's similar to passing an argument in a function inside of some sort of prop. You want to actually set up an anonymous function or a callback function over here that is going to call this other function. And as you can see, this works now. It will fetch the specific ID that we set, and it will get the information. Perfect. Now let's work on the mutation part of React Query. So I created here a create post component. It's a separate one, and we're going to deal with all of that logic inside of here. So let's get started by just building up a very simple form here, which we're going to use to create this post. So I'm going to say form, just generate a form, put an input inside of it. This input will be of type text. So we'll say type is equal to text. And then we'll also put a placeholder. Probably let's just put like post title inside of here. And then we also need to have a button that is going to be used for creating the post. Now, with the JSON placeholder API, they do allow you to test post requests. We're not going to actually add the data into their API, but we will actually see that it was successful. And we only need to pass in the post title for it to work. So that's pretty good for us. We're just going to use it as a testing tool. And inside of here, inside of our input over here, we want to set an onChange, which what it's going to do is it's going to set a state that we're going to create over here that is going to hold the value of this input. So it's going to be a string. Let's come over here and say title and then set title. And on this onChange, we're just going to say set title is equal to the event that we're going to grab from that. And we're going to say event.target.value. Perfect. Now that we're done with that, let's create a function that is going to handle the submitting of the form. So we're going to say handle submit. It's going to have an event here as well. And we're going to first event.prevent default. Then we want to deal with the logic of mutating the data. Now we're going to call this whenever we click on the create button. And this should all be good. Now, obviously nothing happens when we write a title. It doesn't actually fetch data or anything. So let's deal with that. How do we send a post request or a mutation using React Query? So to do that, we're going to also call from the React Query library, but we're going to call the use mutation hook. And you'll see it will auto import. And this hook is a bit different, but not that different. What we need to pass here is, again, a function that will actually make the post request. So let's create here a function called create post. And again, it will be async. And what this does is it will require, first of all, the new post that we're going to add. So new post over here. And inside of here, we're going to say const response is equal to await fetch. We're going to fetch the post route in this API. But it's like posts, and then we'll just make a post by actually adding over here the method and saying that it is a post method. Now let's also pass in headers so that we can specify that the content type is application/JSON. Let me take that out of the way. And then we'll also set in the body. Now the body is just going to be a stringified version of the body, the new post that we're going to pass inside of this function. Perfect. Now we're just going to return the response.json from this function, and we're going to pass this inside of this use mutation. Now, similar to the use query hook, we want to pass an object here, and we're going to pass in the mutation function, and the mutation function will allow us to pass in the create post, and this is going to return to us very similar things to what we got from the use query. The only different thing is it's going to return to us a mutate function that we can now use inside of our handle submit to call whenever we want to actually execute the mutation. Now we do have to pass here some data, and the data I want to pass in is an object that is going to represent the new post. Now I want to have a title, and the title is going to be whatever we got from that input. Now I want to set a default body that we want to add to this request. Let's just say something like this is a new post, and we don't have to pass an ID because it will auto generate for us. Now let's test to see if this will work. Now the only way for us to test again is we need to have our network request open over here and see if there was a successful post request sent when we click create. But let's put a title. Let's say new post, click create, and as you can see, we got a status 201, meaning that we successfully sent the request, and this is what we got back, the actual post that we just created with ID 101, meaning that it's an extra post on the list of 100 that we had before. Perfect. So you can see this is how you generate a mutation and how you create post requests. This would be the same for delete, for updating, for put requests, whatever you want. You would use a mutation for that. Now, one cool thing that in the case where you were displaying the, if I were to, for example, grab this logic over here, actually I'll just grab the posts, and I were to display the posts down here, and then imagine that in the case where we create a post and it would actually add to this list. Because remember, this is not how this API works. They wouldn't just allow me to send actual post requests to the API and add to the data. But imagine that this was the case, that when I create a post over here with the title new post and I click create, it would add data down here at the bottom. Then if that's the case, then this query that is being displayed on the posts component is invalid, right? Because it probably is outdated because this data will now be added to the list, and we probably want to refetch that data because that data now is outdated. So how do we do that? Well, in our create post over here, we can do something really cool, which is we can add some callback functions to if the success came from the mutation, if the error happened, if the mutation is mutating, or a bunch of others. So we want to deal with in case there was success and the post was actually added. What do we want to do? Well, if there was success in creating the post, then let's do the following. Let's call the React query library to invalidate the query that we do in the posts component, this one over here, meaning that when you invalidate this query, it will automatically know that it's not valid and it will refetch the data. So how do we do that? Well, we need to access the query client that we created over here to actually have access to the query that we have in the posts component. So to get the query client in any component other than the one you created it, you can just use a very nifty hook called use query client, and it will give you access to it. Then over here, I'll say query client is equal to use query client. Then I can, on the onSuccess over here, I can just say query client dot invalidate queries. And then I can pass a list.
This is so fucking crazy.
Of queries in which the data now is invalid because of the success of this mutation, meaning that whatever query IDs or query keys I pass inside of this list, it will refetch that data. So in this case, we only want to refetch the posts data, so I'll put it over here, and you'll see that if I open up the network request, let's bring this over here. It'll be kind of hard to see, but let me refetch this. You see we have one fetch for the initial data. Then if I create here the new post, what should happen is we should see a mutation being executed, but we should also see
Things like automatic caching, background refetching, update the stale data automatically and refetches when the window refocuses on the network returns. Damn. Can't we do this? Usable does the same thing, right? Declarative states. Remain all these are already defined inside the Tansha query. Cleans up unused data and garbage collect and old cage entries automatically typed. Update the UI instantly before the server response rollback automatically. This is sounding like automatically. Hey, bro. And yeah, this is for events, I guess. Oh, we even have pagination. What is deduplication? Combines identical concurrent requests into a single network call and saves user bandwidth. Damn. Use query to fetch the API and use mutation to use the state, I guess. You ready? I think he's really neat. I can directly use the data. Those are any errors. Of where the fuck are you getting the error here? I see nothing. I'm even making the call. There are no network calls. This is because of this thing here. I did pass the function. Key is key is really needed for everything like this. 100% right? Yes. Oh shit. I don't even need to read that. Just need to pass it. error handlers are there in the TAN itself, so do I need to put the IN cache? Will it be key? Should draw? Will it work now? Yeah, the API call is not getting called, I guess. Should I call the query thing anyway? Will it directly call the use query or should I call it on not calling it anyway? Like, will it work on or did I miss any written thing? It should be like this. There, then only fetch. Is the API wrong? Five problems? This doesn't bother, like this is not related to this thing, so you can check that thing. So why is this shit not working? Am I doing it right or not? Using the await or saying kind of thing. Let's take this. The API is dead or what, bro? The API is working. What the fuck? Tan stack. Load 175 ms. There are no network calls made to the API. We are having a problem here. See. What is this fucking error? Hmm. Without any errors. Maybe I have to return my thing, I guess. Like let me try to copy this data part. Oh, that was not there. What the hell, bro? This is why I hate frontend so much. Like, I wish it was easy as the backend. Should it be out? My damn thing. Everything should be outside man. And the fetch product is outside of my these things. That doesn't matter, right? Does that matter? Will it really matter to me if I'm going to use it from there or here? It's saying something. What do you want? What do you mean by that? I'm not using it. And constant become something wrong here. What is this error? Ah, it should be thing. Tripping. Will it work now? Was that the error? Yeah, I don't think the position matters in this place. Yeah, but the position matters in other place, you know. Query key is becoming white, but my query function is pink in color. Is that right? Am I not putting the comma? I am putting it. Use query, yeah, man. Like what the fuck, bro? Just let me know what is wrong. Bro, what? Then why the fuck I'm not getting the response? Are you kidding me? I'm having it. Even here I have that thing and some bullshit. Did I install the wrong one? So here we have the issue. Imported query provider instead of client query. Fuck. Oh, man, I think my API should work now. Oh shit, it's not working. Still not working. I have to create the query client first. And then I have to pass the query client. Oh, it's still not working. Instantiate, yeah, I hate that shit. Shit, shit. Yeah, what is wrong here, man? Does anyone know how to use the query? What the hell is it? Tan stack query? Oh, am I tripping right now, bro? I literally see everything to be same here compared to that one. Query client provider, yeah, have the query client provider inside that we have app and we have client, we have the query client, but we will instantiate it. And what the fuck you want from me then? Like, why the hell are you not? Is this right now? Yeah, perfectly right, but properly instantiated and yeah, then why the fuck this is not working? The hell? Even this was right? Bro, if everything is right, then why the hell it is not working? Then why it's not working? I'm gonna tell my brother to check it. Unstack query is not working, bro. I literally have all the setup right and everything is right. He's saying like 100% right, but still I'm not able to see anything. Is this in white color or what? Nothing is there. Like page is literally black. I mean blank. And here we have the API. This is what I'm using. Did I use the wrong API? Didn't I import it? I did it, right? I did it. How are you using tan stack? See, I'm using it here. This is for binding the tan stack with the React project right now, and the tan stack is here. I'm using the tan stack here. See, this motherfucker is not working. I don't know what the fuck is wrong. Bro, what the hell? What is wrong here? Bro, just let me know what is wrong. It's on the top. I think we don't have to call this thing. I think it will call it on own. That's how the AI told me. Like, I don't know. So he's saying something. I'll investigate your tan stack setup. Yeah, let me know, man. What is a bug? Is loading, is error in the app scope. They are distracted inside this thing. So are we using this thing inside the app? Or if for real? What are you saying? They are only destructured inside the tan.jsx, different component, different scope. So app throws reference error is loading not defined at the first render because ever mounts. The whole tree crashes the query. Oh, but never mind what the tan stack itself is wired correctly and throws a non okay response. Fix remove the stray loading and checks from the packages. I don't even have the I don't even have that. Where the hell do I have the you mean you're saying like I can't call the tan since it has this shit in it? So how the hell would you call in the different component? कैसा है भाई? किधर है भाई? लोडिंग किधर है? दिमाग खराब कर रहा है। किधर यूज करना है? क्या यूज करना है, मैं भी देखता हूँ। रिमूव कर भाई, क्या रिमूव करेगा? रिमूव कर। अब क्या कान फट भाई? है ही नहीं भाई, किधर है भाई? छूटे है भाई। मैं कोई और फोल्डर में थोड़ी हूँ। इधर लोडिंग है, इधर लोडिंग है, ये पता नहीं कहाँ से मैच करके आया। चल लोडिंग किधर है? लोडिंग तो है। क्या नशा कर लिया भाई इसमें? लोडिंग तो कहीं है ही नहीं लोडिंग। अरे यार फेच एपीआई है, फिर एक कंपोनेंट है। काम करेगा। अभी आना दिमाग खराब हो जाए। नहीं करना अब क्यों काम नहीं करना? ये एपीआई काम कर रहा है, इसकी वजह से मैं यूज कर रहा हूँ। क्या है यार? हाँ तो फिर काम क्यों नहीं कर रहा है भाई? रीसेट करना बताएगा हर बार, एक बार करके रीसेट करता हूँ भाई। व्हाट द फक, ये कब बंद हो गया? बंद कर दिया गया इसको? सर्वर ही बंद कर देता है, छुट्टी। सर्वर बंद कर रखा था इसने यार। जल्दी कर रहा था मेरे से। बाकी सब सही ही था, मतलब इसमें बंद कर दिया इसको। वापस से चालू करना पड़ेगा तभी अभी गेट दी 1517। Can't stand finally working. Oh shit, 2:39 हो गया है। चल मैं जा खाना खा। फूड फर्स्ट। भाई यार 15 लाइक करो भाई। 15 लाइक। ये वन इसमें क्यों चल रहा है? मेरे को तो इसमें चलाना नहीं है वन वन। उसको क्या हो गया बाबा? ये क्यों नहीं चल रहा है? वही ब्रो, अभी तो काम कर रहा था तू, क्या हो गया तेरे को? नशे में है क्या? इधर काम कर रहा, उधर नहीं कर रहा है, क्या बकचोदी है? ब्रो what the fuck is this bro? क्या पी लिया क्या मेरा ये सर्वर? इसमें भी वाइट पेज। नो, अल्लाह क्या है ये? क्या बकचोदी है ये? इधर आ रही है उधर नहीं आ रही है? गलत डाल दिया क्या? क्या हो रहा है ये? But this is why I hate front end so much. Like there is no fucking anything wrong right now. But still, I'm getting a full fucking white screen, and here I'm getting the whole output whatever was required. Now what should I do now? इंटरनेट एक्सप्लोरर पे चलेगा ये? माइक्रोसॉफ्ट एज? ना ब्रो, क्रोम सैक्स। अच्छा इधर भी वाइट स्क्रीन ना, दिमाग खराब हो जाएगा मेरा। भाई यार, क्रोम में केस कर रखा है बड़ा। ए, अब मैं जो भी आउटपुट देखना होगा यहाँ से क्लिक करके मैं अंदर ही देख लूंगा डायरेक्ट। हाँ चला क्रोम यार, दिमाग खराब हो गया। मेरे को लग रहा था मेरा काम ही नहीं कर रहा है, आई थिंक उसने केस कर रखा है अपने आप। लगी नशे में स्टैंड में रीजन पे भी पकड़। Guys, 15 like guys, 15. Bro, your code is well. Let's learn further. Move on, just like she did, but I couldn't. इसको use कैसे करते हैं? Here are your how to write a dynamic query for every single product in your ID. Product. Query for getting and use mutation for the moves, delete and update again. We have a lot of flags there. Is success, is pending, is failed or whatever. We can use the flag and we can do the things I guess. Yeah. So if I do products, then will it call the fetch product already on its own? Damn. Be right back after my lunch.
Thanks for stopping by my channel. In this video, I want to provide a simple as possible explanation or tutorial for TanStack query, commonly known as React query. Here's what we're going to do in this video. So here's an example React SPA, and it's currently not using React query. It's actually currently not fetching any dynamic data, right? So I have these three different pages. Now imagine for this home page, I want to fetch the data, the JSON that lives at this URL, and then imagine for the about page, I want to fetch this data, and then importantly for the random pet page, I want to fetch this data, which is different every time you refresh it, right? So there's another one if I refresh again. Cool. Now I want to show you how beautifully simple React query makes fetching this data. We're not going to have to use effect, and even if we have different caching needs or opinions for each of these three pages, it still couldn't get any simpler. So imagine for the random pet, because it's different every time you visit it, imagine we don't want to cache that fetch at all. Imagine we want to very aggressively cache the about page, and then maybe we want to be like medium aggressive in terms of caching the home page. All of this is as simple as possible. This is an amazing package. Let's jump into the action and let me show you how you would set this up. So the first step, as you might have guessed, is just to install the package. So npm install, it's @tankstack/react-query. Cool, so we have the package. Now our first instinct might be to go into one of our components and try to immediately start loading data. However, there's a bit of setup we need to do first. And that is because we want our data to be available globally throughout our app, meaning different pages might request the same endpoints, and so we need our caching mechanism or our memory mechanism to live higher up in the app, not in our individual home, about, and random pet components. So what we want to do is wrap our entire app in something called a query client provider. So up at the very top, let's import something. Let's import curly brackets query client provider from, and then @TanStack React query. Now let me show you how we're going to use that. So in our app, just wrap your very top level, so an opening tag of query client provider. Oops, I'm using Windsurf. You might be using Copilot or Cursor, but you can see it's trying to autocomplete, and it's smart enough to automatically add the client prop. You can absolutely accept that auto suggestion, but you could also just add that in manually. Obviously, for this moment, we haven't created a variable called query client, but we'll talk about what this means in just a moment. Let's go make sure we have the matching closing tag down here. So we want to close out of our query client provider. Cool. Now the opening tag does need this client prop. So what in the world is query client? Well, this could be named anything. I mean, this could literally be named pizza. We just need it to be a variable that is a new instance of a query client. So up at the top where we're importing things, you can see my AI tool. We don't need to import query. So far we just have query client provider. Let's say comma, we do need, query client. And then maybe outside of our app, so right about here, you can just say const. Yes, exactly. Because I named this variable pizza, just pizza equals a new instance of query client.
At this point, our wrapper now has everything it needs, and now anywhere inside of it, it's super easy for us to leverage React Query. So we can save this file, and now we can start going into our individual pages or components. So let's go into our home page. And now remember, for the home page, I want to fetch the data that lives at this URL. So up at the very top of this file, we're just going to import use query from, you guessed it, @tanstack React Query. So even though this component has no idea about our overall caching store, because we're using this, it's as simple as just like using, like use state or use effect. You can just say const. And you know what? Instead of typing it out, I actually recommend just going to the official React Query documentation. And on the homepage or the overview page, I should say, their example code is perfect. So if you scroll down a little bit here inside of their component, here you see this block of code. I would actually just copy all of this. So is pending error data. You're going to get the loading ... If there's an error, we can show that. And then this little block of JSX. Just copy all of that into your clipboard. If you don't want to do that, I will include a link to my finished product code. But check this out. Inside our home component, inside the body of our function, I'm just going to paste in my clipboard. And let me walk through this code with you. So we're destructuring these variables. And the key here is that we're leveraging or using use query. Query key is very important. This is the unique identifier for this piece of data or for this request, or I should say this query. Why don't we call this one like homepage data? You and I will not have to type this in anywhere else. This is just for React Query's sort of internal management. Okay, and then query function, this is just a fetch, and then obviously whatever URL or endpoint. So for me, it's just localhost 3000, but whatever you're trying to fetch, just include that here. So while this is fetching, we'll see loading ... If there's an error, you get the idea. But once it's successful, once we have it, let's just say like, homepage content, and then inside the paragraph, it would just be data dot, and then in my JSON, I have something called content. So let's save that, and if I go back and refresh my homepage, beautiful, you see loading ... And here is the dynamic JSON value. Let me set up the basic query for the about page and the random pet, and then I want to spend just a minute with you really understanding how caching works in React Query. So we'll implement different caching strategies for each of our 3 pages so that it's optimal for the needs of that content. But let's make the about page come to life. So I would actually just take my home component, go into about, just completely wipe it out, change the name of the component to about. Definitely be sure to change the query key. Let's call it like about page data. And then what we're fetching is just /about. Let's change this to say about page content. And then data.content, so we can save that. Now when you visit the about page, beautiful. Let's set up random pet. So I would go into that component, paste it in, change the name to pet. Definitely change the query key to random pet. Let's change this to /random. Down in the heading level 1, let's display, so curly brackets, data.pet for their name. And then let's also display their weight. So data.weight and then pounds. Let me save that, let me refresh. Loading ... There's the name, there's the weight, beautiful. At this point though, let's spend a minute to really understand how caching works in React Query. Now, to make this really obvious, I've actually made my endpoints take a whopping 3 seconds to actually give you the data. Like if I hit refresh, it's going to take 1,000, 2, 1,000, 3, 1,000. This will make it crystal clear and really easy to understand the way that React Query by default uses cached data but fetches a fresh copy in the background. So here's how we're going to make sure that we perfectly understand how this is working. In my endpoints for home and about, I have something called our number that's going to be a random value each time you load it. So you see 3 seconds later, it finally spits back a different number. So let's just make sure we're including that in home and about. So let's have a paragraph that says data.our number, and then let me just be sure to include that in the about component as well. Cool. So now if I go back to my application and then open up your dev tools, and 2 things, go into the network tab, and then in addition to the network tab, I want to enable this cool feature. So from these 3 dots, more tools, I'm looking for the one called rendering, and then make sure you enable paint flashing. This will highlight in a green rectangle the parts of the DOM that are actually getting repainted. With our dev tool set up, now let's spend maybe the one called efficiency, include that in the about component as well. Cool. So now if I go back to my application and then open up your dev tools, and 2 things, go into the network tab, and then in addition to the network tab, I want to enable this cool feature. So from these 3 dots, more tools, I'm looking for the one called rendering, and then make sure you enable paint flashing. This will highlight in a green rectangle the parts of the DOM that are actually getting repainted. With our dev tool set up, now let's spend maybe the next 70 seconds just really understanding how React Query works by default, and then we can learn how to fine tune or customize those defaults for each individual page. So if I just refresh my home page, and then let me clear out the network tab and make sure under the requests, show all of the requests. Now when I click on about to visit that page, notice there's just that one request. It takes the 3 seconds to load, and then it displays. But now let's remember this number, the random number, so 449811, or just that it ends in 811. Now if I go to the home page and then click back onto the About page, notice it's showing the old number, and then 3 seconds later, it has a brand new number. But we never saw loading ... again. So by default, React Query, you can see now when I click between these, it's instant, and that's because it's showing you the cached or the data from the previous request, and then in the background, it's fetching a new copy. So like, notice this one ends in 168. When I click back to it, we don't see loading ... We're seeing the old data, and then in the background, it's performing that request, and then only updating, well, I mean, that's due to the nature of React, not React Query, but then only the part that's different gets re-rendered. The key here is that even though your data is cached, React Query is still, and that's why I wanted you to have your network tab open, it's still going to send requests every single time I click back and forth between these two pages. You can see each time there's a request to About. When I click Home, there's a request to Home. When I click About, you get the idea. So that's the default behavior for React Query, and I think it's a very intelligent default option. You're getting the best of both worlds. You're getting instant cached-based display, and then you're still getting to know that you always have the fresh data coming in, just a little bit later. So that's a brilliant default, but what if you want to customize that default? For example, on our About page, what if we don't want to have subsequent network requests for About? Like, what if you know that your About page only changes once a year? So as long as that's in the cache at all, just display it from the cache. Don't bother with another network request. It couldn't get any simpler. Check this out. We just go into our About component, and then inside of use query, we have query key, query function. Just add another property called stale time. It's measured in milliseconds, not seconds, but let's just say half an hour. So 1,000, times 60 times 30, comma. And now if I save and refresh, let's take a look at our network tab. Let me actually go to the home page and refresh, clear out the network tab. So the first time I visit the About page, obviously we see that network request. But then if I go back and click on About again, beautiful, we don't bother with a fresh request. But our home page still is having those background to always pull in the newest data. Beautiful. Now let's focus on our random pet page, because with random pet, because it's different literally every time you hit up that endpoint, if I navigate away, I don't want to see the old data at all. Anytime I click back onto random pet, I want to just immediately see loading ... That old cache data is completely worthless here. So all we do, if we go into our pet component, in addition to query key and query function, this time, not stale time, but something called GC time, which stands for garbage collection time, and just put it to 0 so that it's immediately cleared from the cache. It's immediately thrown in the garbage. We don't ever try to use it again. So if I save this, and let me refresh my home page. Okay, when I click on random pet, we see loading ... But that's not the moment of truth. Now if I click off of it and then click back onto it, beautiful. I don't see that old pet. I immediately see loading ... And every single time you're just going to get that exact behavior. This is exactly what we want. Now, to clear up any confusion, the difference between GC time or garbage collection time and stale time is that stale time controls how long before it's considered stale so that it will fetch a fresh copy in the background. GC time controls how long it will be stored in the cache. Now, we've only scratched 1% of what React Query is capable of, but I've found in my simple projects that just GC time and stale time, just this alone is already so powerful and so easy compared to using useEffect. This is just amazing. I'm a huge fan of this. I'm going to be using this in all of my spa projects moving forward. That is going to bring this video to a close. If you enjoyed this video, and if you're a fan of using React more as a library instead of as a server-side framework, you might be interested in my full React course. In the description, you'll find a link to join my full course. In the course, we build the front-end spa for a social network where you can log in, create posts, follow other users to build your homepage feed. There's a live search and a live chat feature. It's a lot of fun, and it's really just focusing on using React as a library. Anyways, thank you so much for watching this video until the very end. I hope you
rendering or static site generation. And if you struggle here, you'll end up sounding mid-level at best. In this video, I'll walk you through the evolution of frontend architecture from static pages to MVCs to single-page applications, backend for frontends, modular monoliths, and micro frontends. What are the trade-offs, and when should you pick them? And at the end, I'll also give you a frontend architecture audit, which is basically a checklist that you can use to make sure that you think and you express yourself as a senior engineer in the frontend interview. Before we start, how did we even got there? Well, the web started just as static HTML and CSS with tiny scripts, just a sprinkle of JavaScript. Super fast, but zero interactivity. And this really looked like magazines. You can think of it as a newspaper, just text and images, but zero interaction with the user. And that's why the first architecture style came in, which was the model view controller. Pretty much all big web frameworks implemented MVC in the beginning, including Django, Ruby on Rails, .NET. Basically, in the MVC model, what we do is that we still create that static view. We still create our HTML and CSS, but we do it with a model and a controller that run on the server. So we use a server language like PHP or Python or Java to mix together certain elements and data and then spin out that tailored HTML. Basically, the MVC allows you to create better, more interactive web pages, but it's still very poorly scalable. The performance is not too great, and you need to reload every time you go to a new page. The complexity is pretty low. The size of the team that people can work on, it's also pretty low. And again, the product value comes from the fact that everything is dynamic and you can implement more complex logic than in static pages. But it comes with very tight coupling between the backend and the front end and very poor scalability. And there's also a bit of framework lock-in because it's extremely hard to switch from one of those frameworks to the other. Now, the MVC really revolutionized the web in the early 2000s, but then JavaScript happened and basically the revolution of the single page application started. Now, you probably worked with a single page application where you have your SPA written in React, Vue, Angular, or any of those frameworks, and then you have some sort of a backend API, which is our old view, but now it's a model view. Basically, we just use it to fetch data, but a lot of our logic moves to the front end. And that gives the web page a lot more interactivity because you can request data and make changes without reloading. So we move authentication, validation to the front end, and we start having things like state on the front end, which wasn't the case. Now, SPAs are great and they definitely scale a lot better. They have better performance, especially when it comes to interactivity. They're very fast because you don't need to navigate to a new page. The complexity is higher because all of a sudden you need a front-end engineer. So basically when SPAs were born, the front-end engineer was born because again, we're offloading all that. We're moving all that logic to the front end. You can have a bigger team and a lot more product value. So when JavaScript frameworks appeared, you start having these complex products like dashboards, very complex apps, and basically mostly product companies that were building web products, which was pretty new. And this was all enabled by those frameworks. Now, the cost is higher than static pages, but still very manageable. Remember, they are rich, interactive, very scalable. They can handle complex state management, so you have a lot more product value, but there's too much JavaScript, and usually you get a very poor loading time because all of a sudden the browser has to parse and download all that JavaScript to be able to show something. And because you get this initial empty page, you also have very poor SEO. Now, before we move on, keep in mind this key concept, which is thick clients versus thin clients. Basically, a thin client would be your static page that delegates most of its logic to the backend, whereas a thick client, a fat client, would be one that has a lot of logic and a lot of business logic, and it's using the backend more as a storage. So what we'll be moving from, it's from thin clients to thick clients by adding more and more logic to them. There's different advantages and disadvantages of having that logic on the front end. I will not get too deeper into it, but do make sure you understand the difference and to what extent should your client be thick or thin. Now with single page applications, we only solved part of the problem. And as the web grows and grows, we start having mobile devices. And with mobile devices, we have new clients, all of them requesting the same API. And that's when the BFF pattern appear, which is the backend for frontend. So basically, with the backend for frontend, we split our backend and each frontend application gets an individual backend. So they don't share the same one. And the reason for this is because a mobile application has totally different views. And so it might request the same data, but in a different shape than a desktop application. And if you try to put all that in a single backend application or in a single API interface, it will be a Frankenstein. So it's much better to separate them. Why is this important for you as a front-end engineer or a full-stack engineer? Because most of the times, the backend for front-end, it's owned by the front-end team, by the client team. So all of a sudden, the front-end engineer also needs to know full-stack. Even more important, GraphQL came to solve a lot of the problems that we had with REST APIs. Those are overfetching and underfetching. And although it's a very good tool, it also added new complexity for us. Because when building a GraphQL server, you need to worry about the N+1 problem and thinking graphs and scalability, and so everything became a bit more complicated. The advantage is that behind the GraphQL server, you have many different microservices. You can have individual backend teams working off those services and releasing software every day, and at the same time, the front-end team can work uninterrupted on their own features. So all of a sudden, you could scale in terms of people. You could build much bigger teams and much more complex products. So the backend for frontend would give you the Taylor endpoint, a lot of a faster iteration, and aggregated services, because with a backend for frontend, you only need to implement authentication once, you only need to implement HTTPS handshakes once, you do it with the backend for frontend, and then you're okay with any service that's downstream. But at the same time, you have tie coupling, and you have scalability limits, and it becomes a single point of failure. So the scalability is slightly higher than your SPA. Performance kind of stays the same. Actually, it's a bit lower because you have this extra trip to the network because we added this new piece in between. The complexity is higher, but you can grow your team. And so you can build much better or bigger products. And that's why the product value, it's bigger than with the SPA. Now, the upfront costs also increase because you have more infrastructure to run and you have a lot of learning. You need to make your team kind of adopt GraphQL. So that's usually a huge upfront cost. Now, we did solve the backend problem, but there's still a problem on the front end that we didn't really talk about, which is the fact that single-page applications ship way too much JavaScript and users are staying at an empty screen without too much happening. So how can we solve this? Well, that's when SSG, ISG, and SSR, server-side rendering, appeared, and all those fancy frameworks we use today, or meta frameworks around React, around Vue, which are Next.js and Nuxt.js and the like. Basically, what we do with SSG, which stands for static site generation, is that we are going back to the future, actually back to the server, and we generate static pages. So whenever you don't need interactivity in the front end, you can still use React or a modern framework, but in the end, ship to the browser static pages that you host in a CDN, which is a content delivery network, and so it's blazing fast. Again, this has very little interactivity, and you cannot really update your content unless you rebuild and redeploy your website. So it definitely comes with disadvantages, but again, it's blazing fast and very cheap. Basically, we're back to that initial web, but with all the modern tooling and modern frameworks. The evolution of this would be incremental static generation, which is ISR. In ISR, you basically regenerate pages based on a TTL, time to live. So if users make a request and it's been over a certain time window, then you can go back to your data store, content store, regenerate that, and replace it in the cache in the CDN. This allows you to change your content dynamically. So if somebody updated that content in the database, then the regenerated page will contain that update better than SSG, but still not good enough for us to build anything interactive. And so the next approach is server-side rendering, where we take our JavaScript framework that we used on the browser, but now we run it on the backend, we pre-generate our initial HTML, and we send it pre-rendered to the client. And so the users are not staring at an empty page. They really get something. The problem here is for us to make that page interactive, there's still a lot to do. And this is what Next.js and Nuxt.js, all those frameworks kind of solve this problem of rendering on the server that initial page with the initial state and sending it pre-rendered to the browser. However, to finish the story, we'll still need to end up downloading our SPA code and somehow make our initial pre-rendered HTML interactive. And the way we do that is with hydration, where you'd get that pre-rendered HTML, the browser would render that, the user will see something, but then we download our JavaScript bundle, we run, we execute our JavaScript framework that will build maybe a virtual DOM in the case of React, and then we hide it. We attach the pre-rendered HTML with the internal component structure that was rendered by React. We did solve this problem of seeing something very fast on the screen, but interactivity is still very much delayed. It still takes a long time until the users can actually interact with the web page. I mean, in the meantime, they might click on buttons and nothing will happen, which is not ideal. And that's where the last stage of evolution comes, which is using tools like React Server Components, where you will strip down your component tree from all the components that do not have any interactivity. So your tree on the server will be the original one, but your tree on the client, your component tree, will be much smaller. And so in that way, you ship a lot less JavaScript and you are able to have even faster interactivity so the users can interact with the page much, much faster. You literally only ship JavaScript you need. There's different philosophies that follow this, and you have the island architecture. I won't touch on that. That's from Astro, a very interesting thing. But for now, if you can explain React Server Components and know how to use them, when to use them, that's more than enough. They are basically implemented by default in the latest versions of Next.js, so you don't need to worry too much, but you do need to know you're not shipping the whole component tree, but only parts of it, and that's what solves the problem of interactivity. We saw all these different ways of improving the performance of our SPA, and as you see, this is literally the most performant way to build applications that we know. It will increase your SEO, it will load very fast. In terms of scalability, it's less scalable than an application that is client-side rendered, because if you just have assets that you ship to a CDN, that's very easy to scale. But now that there is server work right into pre-rendering all this, then you need more complex infrastructure and more expensive infrastructure to make this happen. The complexity is extremely high. All this technology comes at the price of knowing a lot more. It's harder to onboard developers. It's very framework opinionated. So whenever they change a version, you need to adapt. And so in general, the cost is higher, but you get more product value if you have a use case that needs performance or SEO, like for example, e-commerce. I know a lot of companies that migrated to Next.js prematurely and now they are rolling it back. So be careful. Only use this if performance is really a bottleneck in the product. Now, I mentioned a lot of different terms that I've been throwing around. If some of them are unfamiliar or you feel like you have certain technical gaps, take a free technical assessment. We build it with real interview questions, and you can literally find your gaps and where you are in the spectrum to senior. Check the link in the description. Now, we've been talking a lot about web performance, how we made our SPA faster, but not a lot changed in the single page application itself inside it. And as it got bigger and bigger, we need a new way to handle it. And that's where the modular frontend monolith comes in. With the modular frontend monolith, our SPA got so big. Now, to give you an example, I've worked on client applications where we had 300 developers contributing to the same code base. It's extremely hard to maintain code quality and keep shipping without someone breaking something when the code base is so big. So what we try to do at that level is to add boundaries between modules. You can basically extract our shared UI on logic, the design system, the global CSS, maybe some reusable hooks, and also extract shared services like auth, data fetching, logging, and analytics. All those things are shared and maintained by what you usually call the platform team or the front-end platform team. But then the actual developers that are building features, they are working in domain teams. And so basically everything that has to do with user, we will isolate that in the user domain and then in payments. And obviously our folder structure would follow that. This is one of the ways to really quickly put some order in a big single page application monolith. To implement this, we can draw ideas from classical software architecture. And the most common one you probably heard about, it's clean architecture. The problem with clean architecture is that it's very abstract and is very optimized for the backend. But you can think of it as domain-driven architecture. And to give you an example in React, you would basically try to extract from your application the most generic entities like a user, product, whatever your business case is, and then make everything else depend on them, but keep those stable. What does that mean? Well, in practice, your code will look a bit like this, where at the very top, we have our domain, that's our user, but then we create use cases, repositories, and finally, our infrastructure layer, our framework layer depends on that. What's the beautiful thing in this code example? You could literally change the snippet of the React component with a Vue component or with an Angular component, and you have to change nothing at the other part of the code. So basically, you have an application where you could entirely swap your front-end framework, and you wouldn't have to change the whole thing. You keep a lot of your code, it's what you call stable. Now, is this really relevant in the front end? Have you ever seen an application that implements clean architecture? Well, the short answer is sometimes. The reality is classic architecture doesn't apply too much in the front end because most front-end frameworks are already opinionated. They come with a certain structure. The front end is usually thin. You don't start from scratch and you don't have all that logic that usually we have in the back end. And yes, it is useful if you change framework, but how often during the lifetime of a project you'll actually have to change framework? I mean, maybe some projects that are very long-lived will have to, but most projects will not have to. And so investing in those abstractions to make that possible, it's usually just over-engineering. And finally, it is good for you because it helps you think about how decoupled code would work. So as a mental exercise, it's very good, but be very careful. I would only apply it to very big front-end projects or projects that, will have a very long lifetime. Like they'll be around for the next 15 years. Another version of classical architecture is the hexagonal architecture, which is more focused around how you connect external dependencies into and how you plug them into your domain. I won't detail on it because again, all those ideas are very much in the back end, but they're not so relevant in the front end, but do keep it in mind. Again, they're all based on this idea of onion architecture, where at the center of the onion, you have the most stable part of your code base, which is your business domain. In reality, if you're working on the front end, you'll probably use a framework. And here's an example of how Next.js, it's quite opinionated on how you should structure your code. And if you follow that, you'd be okay in 99% of the cases. Going back to the front end monolith, as we see, it's definitely as scalable as our single page application. We can work with a much bigger team, but there's definitely a price of complexity and cost because you do get this cohesion and we have a global state. There's a very long build time and it's very hard to really enforce those boundaries. So it's extremely easy to draw some domains and pretend people will stick to that. But in reality, you end up with dependencies all over the place. So the idea sounds good, but then in practice, it's quite hard to be very disciplined about it and implement it well. Finally, we have micro frontends, and this is where the single page application meets enterprise software. In micro frontends, we literally take those domains and we deploy them as independent applications, and then we put them together at runtime. So basically, the users, the header, the footer, all those things can be independent front-end applications. And then there's a shell component that takes them all and put them together. And the shell has kind of the shared CSS, the shared state that will then inject in those frameworks, but that will inject in those other applications, but they're all on different domains. The teams working on them are independent and they can deploy code independently. And that makes it possible for a lot of developers to contribute on the same front-end application. Again, it's a very cool concept, but it requires more technical investment and there's more moving parts and a lot more complexity. And so the way this will look in reality is that you can look at your web page and kind of split it by teams, and those teams will have vertical slices where they own the backend and the front-end part of that, and they're all independently deployable, so everybody works in parallel. When you have a big company with thousands of engineers working on the same client application, you need to use micro frontends. But if you're a small company and you go into this, you will basically shoot yourself in the foot because there's a lot of complexity and you'll actually be slower, not faster. So keep in mind that micro frontends are very scalable in terms of development speed. You can have a lot of people contributing on it, but performance will suffer because we're putting all those applications together when the user lands on the page. You can use things like Webpack Module Federation for that, but you do have a slight decrease in performance. The complexity is really high, but a huge team of developers can work in parallel. So if you manage the complexity, if you have very great engineers, then yes, you can expand your team size. The product value is extremely high because you can build things that weren't even possible on the web, like huge e-commerce store or complex software like image editing or video editing. But the cost, it's extremely high too. So it's only in very big companies with very mature projects where it makes sense to really invest in micro frontends. However, we see this a lot in interviews. Even smaller companies might ask you, how would you do micro frontends? Because they have a bit of FOMO and they want someone that knows how to do it. So do make sure you know at least when do they make sense and at the high level how it actually works at a high technical level. If you want me to make a video specifically on micro frontends and the underlying technology, let me know. And finally, what I've been promising you, which is the extra architecture audit. So you make sure that you can stand out in the senior interview. Basically, what you want to do is to sit down and research your current code base. And the question you want to answer is, what is your current architecture start? Why did you land it there? And what would be the next natural next steps? So you want to write down on paper, are you doing an SPA? Are you doing a static page? Are you doing MVC? Or do you have a backend for front end? What are all the patterns that you are using right now? And you can refer back to this picture and see how many of those or which one of those you're using. Now, finally, in your next interview, whenever they ask you about the project you're working on or the application you're working on, you want to go from, yeah, we just use React and Next.js to a senior answer that will look more like this. We serve static pages via static site generation and use SSR for personalization. But then we structure our repo as a modular monolith. As we scale, we did consider micro frontends down the road. That would be a very solid answer. And that's the kind of answers that make sure that you then get what we call a backend rejection. And a backend rejection in interviews, it's when they tell you it was all great, but then a couple of days later, you get a generic email that says, yeah, we really liked you, but we ended up picking someone with more experience, or oh, we found someone that was just a better fit, but we will keep you in our list of candidates, blah, blah, blah. So those kind of things happen, not because you did anything wrong, but you haven't done enough of the right stuff. Now, if you do want to learn more about how to stand out as a senior in the current job market despite layoffs and AI, make sure you check out the free training. There's a couple of the mental models that I mentioned that are also being mentioned there, and how you can plug them in as a roadmap for you to really fast forward to that senior level, think like a senior, and also get a senior level job with a senior level salary. As for me, I'll see you in the next one. If you're a front-end engineer, everybody tells you get to senior, but no one tells you how. We've analyzed over 300 senior front-end engineers. Different backgrounds, different frameworks, and one pattern came up. Every single one of them has mastered these 15 core front-end mental models. Most developers can't even explain 5. That's why they get stuck at mid-level for years and keep failing technical interviews. But master all 15 and you'll easily move up into the top 10% front-end engineers. And of course, get to senior. Number 1, the critical rendering path. The critical rendering path is the steps the browser needs to do in order to go from HTML, CSS, and JavaScript to pixels on the screen. It all starts on the server where we get our HTML file. And so the browser will get this markup file and starts reading it. And it will probably find some links to more CSS and JavaScript assets, maybe some fonts. And based on those files, it will go ahead and download those, parse them, and start building, in the case of the CSS DOM. That would be the reflection of the DOM, but with CSS, basically building all the CSS you'll need to render the DOM. And with the JavaScript that it will find in the head section of the HTML document, it will build the DOM. And so it has to do all this to build the render tree. And once it has the render tree, it can start the rendering process. Now, the rendering process has 4 steps. We need to first style, then layout, then paint, and finally composite to finally display pixels on the screen. And all this has to happen until the user sees something. And that's what we call the first contentful paint, which is our first milestone in the rendering process. Now, if this sounds like a lot, don't get scared. By the end of this video, you will master this because a lot of the concepts that we'll introduce later on, they always relate back to this main mental model. Now, let's get a little deeper. Whenever the browser receives a document like this one, it will start reading it top to bottom. So it will go through each node, slowly, little by little, and interpret it. Whenever it finds a resource like a CSS file or a JavaScript file, it needs to go to that server, download it, and render it. And finally, we get to the body where the actual things are and render our first H1. The resources at the top, we call them render blocking because in most cases, they need to be downloaded, parsed, and interpreted before we can move on. And the element at the bottom, that would be our first contentful paint. That H1, it's actually our first element. And here goes the first senior developer tip. Whenever you are explaining something, don't jump straight to framework talk like, oh, React, Vue, or Next. Instead, you want to focus on the underlying principles like the browser mechanics and use frameworks as an example of an implementation. Now let's move on to number 2, the core web vitals. The core web vitals are basically empirical metrics that measure how fast the page loads and how fast it responds to user input. And there's mainly 3 of them. We have the largest contentful paint, the interaction to next paint, and the cumulative layout shift. These 2, the LCP and the CLS, are basically measured during the initial render. The IMP, the interaction to next paint, it's actually measured while you re-render. So it basically tells you how fast the page will re-render after the user clicked on a button, for example. You can think of those as performance benchmarks. A good analogy would be Formula One cars that you can actually classify and benchmark based on their top speed, their agility, their downforce, their aerodynamics, and you can have empirical metrics that basically measure all those, and that's how you can classify. And so in the case of a website or a web application, you can actually benchmark your application against the average in the industry and figure out how well you're doing. Now, I just ran this analysis on our website, and although we have a very good CLS, our LCP, for example, is pretty bad. So I'll probably have to go ahead and improve that. Now, how do the core web vitals relate to our first mental model, which was the critical rendering path? Now, remember the critical rendering path were all those steps that needed to happen before we have that first pixel on the screen. But once that happens, we keep rendering. And so as the browser keeps finding HTML markup, it will keep rendering those incrementally all the way to the bottom of the page. And along that process, it will render the largest contentful paint. That means it will display one of the largest elements that's being calculated on the website. And that's the first core web metric. Now, in general, this would probably be an image, because if you're working with e-commerce websites or SaaS websites, then probably be an image or a piece of text, but it's mostly images. Finally, during this whole process, as you render your web page, there will be changes in the layout. You might have CSS coming in that changes everything, or new elements that are being rendered, and that will generate layout shift. So what the browser will do is to take screenshots of the web page and then try to measure and make sure that there's no big shifts. And that would be your cumulative layout shift metric. And finally, once the page is rendered, you might have the user clicking or typing on something, which usually in modern frameworks creates a state update. From that state update, you have a re-rendering of your component framework and what we call the reconciliation process, which will finally trigger a browser re-render. The time we spend basically from that user interaction to doing the state update and finally the reconciliation, it's the IMP, the interaction to next paint. So as you see, a bit of a different metric, but it basically measures that when you go to the website and you start clicking around, it keeps being fast. It's not only about loading speed, it's also about responsiveness to user input. Now, before we move on, I'm going to introduce myself. I'm Bogdan from the Senior Dev. I started the Senior Dev with my brother that I was 5 years ago, and we basically help JavaScript developers get to the senior level with the right mental models, with a proven roadmap, with feedback on what you're doing so you know you're doing the right things, and with a global community. We've already worked with over 350 mentees, and if you want to know more exactly about how this works, check the link to the free training and the roadmap in the description. Moving on to concept number 3. HTTP caching. Well, before we start talking about HTTP caching, we need to talk about caching in general. And caching is a pattern based on a core mental model, which is memorization. And you'll see memorization at every layer in any kind of application. You can have memorization at code level, you can have caching at database level, but at the end of the day, it's always the same pattern. So basically memorization, it's reusing the output of an operation for future queries if you get the same input. And so this is probably the most accurate description of it, whereas you see the security guard is pretty much applying the same treatment. Probably not good from a security perspective, but it's literally reusing the behavior. Now moving on to caching, especially at file level, it would be reusing the same file for a predefined amount of time. That's the TTL. And so if the user tries to request that file again, we will give them the cached version. We will reuse it, so we don't need to go to the server and then download that, which usually takes longer. And the TTL, as I mentioned, is that time that we should consider the cached asset fresh. You will see TTL settings at DNS caching level in your CDN, and so now you know basically what it means. Now back to HTTP caching. We usually have a browser and the browser has a cache. And then we have a server. And so it all starts with a request for a specific file. Like let's say we need our bundle or we need to fetch a CSS file. We will send that request to the server. We'll say, I need this file. Because there's nothing in the cache, we cannot really use an older version. And finally, the server has that file and it will send it over to us. But as it sends it over, it also gets stored in a cache if it has the correct cache control policy. So in our next request, we will actually go to the cache, get the file from there, and use it. So we don't need to go all the way back to the server again. And finally, that's what we call the TTL, is the time we are allowed to do that. Because at some point, the asset will expire. At some point, they will say, hey, you know what? Go check if there's a new version. And when that happens, we will go and check, hey, is there a new version? And if there is a new version on the server, then we finally make that request. That's what we call a cache invalidation request. And it's basically managed with the etag header. If you go to any request you're making, you'll probably find a cache control and the etag header. And then we will get the new version. And then again, that will be stored in the browser cache for whatever the TTL was specified. Now, the way this is done in the browser is that it's all done with the request and responses. I invite you to go to any website you like. And in this case, I chose Walmart. I've basically went to the developer tools, chose a CSS file they have, and we can see the cache control policy where they set that max age to 3 million milliseconds. But basically that means after that time, we will need to go and check the etag again with the server and figure out if our cache is still fresh. And if not, we'll need to download the new asset. You can find this in pretty much every website. Now, we don't usually have to set the caching policies ourselves because it's usually the CDN that will do it for us. And a CDN is basically an infrastructure piece where you can put your static assets and it will push them to different edge locations. So whenever the user will try to access that resource, they get it from the edge location that is closer to them. So we are more efficient just because we are closer to the user, but it also usually applies the right caching policy and it applies the right compression policy. So it comes with a lot of optimizations out of the box. It's probably the best thing you can do from a performance point of view for a web application. And the first one, basically the CDN will become our server. So whenever new static assets are published, so imagine you recompile your application, you release a new version and you have that JavaScript bundle and the CSS files, they would go to the CDN and the users will get them from the CDN. And so basically it's used to distribute static assets to those edge locations across the globe for very fast access. And out of the box, it gives you all these implementations like an efficient cache policy and compression, which is done through content negotiation. And that's our next key mental model, content negotiation. So basically content negotiation is the process in which the client speaks to the server and whenever it needs a file, it will send out some headers. Usually it's the accept headers. And in the accept headers, it will mention that there's different encodings for that resource. So it will basically say, I want the JavaScript file, but you can give it to me compressed. And the two most popular algorithms for compressions are gzip and broadly, with broadly being actually the most efficient one. So it will basically mention, hey, you can give me this as a gzip or a br, which stands for broadly. And then the server will look at that request. It will look at the metadata, the request headers, and figure out if I have a more optimized version of the asset, like a gzip or broadly, then I'll give it to you. In this case, we will send over the gzip version. And of course, we need to add to our response headers the content encoding gzip. So then the browser knows, okay, I have a CSS file, but it's being compressed. So I need to decompress it really fast. The reason why this works is because it's cheaper to decompress things than to download them in their initial version. So that's the math behind it. It's cheaper to download very fast a smaller version, a compressed version, and decompress it than download the original. Now, content negotiation, it's one of the core mental models for the full stack. And if you want to know even more of them, then go ahead and take the free 10-minute technical assessment where we'll basically help you figure out where you are in the seniority scale. And a lot of the questions you'll find there are actually real questions. questions from interviews, so it also gives you an idea of where do you stand technically in the market. Now, before we move on, our second senior developer tip is that senior front-end developers are expected to have very good fundamentals of the data layer too, things like HTTP, GraphQL, REST APIs, or even WebSockets. So make sure you invest time into those too, so they don't become a blind spot, because it's extremely hard to get a senior front-end position without knowing at least the fundamentals of HTTP, TCP, HTTPS, and REST APIs and GraphQL. Let's move on to our fifth mental model, which is lazy loading. Basically, the opposite of lazy loading is eager loading, where we load everything at once. But again, those things would be very heavy. In this example, I have images, and we load the 4 images on the spot. A better way would be to implement lazy loading, where we only load assets where they are needed. When the user does something and they actually need that specific image, then we give it to them, especially if it's not needed in the initial render. So, as you see here, those 2 images are loaded when the user will scroll, rather than loading them on the initial render. That's a lot more efficient. Now, can we lazy load JavaScript? And the answer is yes. But to do so, we need to rely on dynamic imports. And so traditionally in your code, you probably use static imports like this one. This kind of import is evaluated by the module bundler at build time. So whenever we run our build before we deploy the application, that will be interpreted and it will be all added in a single bundle. It will be included in the main bundle and then shipped to the browser, and then the browser will execute that as soon as it gets it. Basically, it becomes one of those critical assets that blocks rendering. The strategy for us to make loading more efficient is to move all those things that are not needed to when they are needed. Basically, we import a JavaScript script at runtime. Just after the user did something, we go and fetch that document and we execute it, versus a traditional static import that was done when we build the app. And that's how it looks in the code. We have that click event, and whenever that will run, it will actually run an asynchronous function to download that model JavaScript, the JavaScript we need to open the model, and then finally we'll open the model with the function it got. But basically, again, it needs to go to the server and get that chunk, that leftover part. That part of JavaScript will be fetched and executed at runtime, so there is less initial JavaScript that we need to run. Now, dynamic imports are one of those core fundamentals in JavaScript, and if you want to find out more, check out the JavaScript interview cheat sheet at the bottom, where we basically put together 25 of the most common questions, and make sure you review that before your next interview. Moving on to the next concept, let's talk about bundle splitting. So bundle splitting is basically lazy loading applied to our JavaScript bundle. Traditionally, we would have a lot of source code in different files or modules, and all that would go into our module bundler. In this case, I chose Webpack, but it could be Vite or any other module bundler. Basically, this module bundler would put all together in a single production file. That was a big advantage, and that's why we basically use module bundles to put everything together, because it would be impossible to include all our files into the head section of the HTML file. Now, the problem with that production bundle is that it's being used on every single page, and so everybody gets all this JavaScript in the beginning. And as you saw, all this has to be parsed and interpreted before we show anything to the user. So you'll have a lot of performance problems if you just keep everything together. And with bundle splitting, we are able to split our bundle into smaller subsets that are being used on different paths. So basically, we take all our dependencies and we put it in our common.js or vendor.js, and then we split all the other paths into login, home, dashboard. So when users go and load the dashboard, they don't need all the JavaScript needed in the login section or settings. This optimization is one of the easiest to set up if you're using, for example, a Webpack and a React Router, and it's how most applications work today. And there comes my third senior developer tip, which is you always want to think in systems, components, and relationships rather than memorizing. And I hope what you got so far in the video is that we start with the mental model, but then it's related to everything else. The critical rendering path, it's related to things we do with our module bundler, and it's definitely related with our core web vitals. And that's the way you want to learn. Never rely on memorization. When you go to interview,
Amazon. Most of these files were scaffolded files such as index.tsx and so on, but I also added routing because every app pretty much has routes. So we're gonna go over all these folders one by one, but I'm gonna start with components. So inside components, we have different folders such as home folder, login folder, product description, and shared. all these folders act as components, but also like pages of our applications, and they're going to be referenced from our router. Every component has a test for it because we are a good developer and we always make sure that we have tests for our components. But basically, these components, such as login, which has a similar file structure, product description, all these components comprise of shared components such as button, button group, card, and so on, that act more like a molecule inside or atom inside the molecule. So what you could expect inside the button is something like this, where you have styled components, for example. You define different button components with some cool CSS, which is also flexible, and export it and import it in your components and reuse across your whole app. So this is very cool, but we also have context folder, where you can use React context files to share the data across your application from parent to children. We also have hooks because everyone uses hooks to, for example, to fetch the data, to manipulate local storage. We also have services file where, for example, in api.tsx, we're going to have predefined functions to talk to our backend APIs and navigation to do some metadata when navigating through the app. And we also have some utils because Amazon is a multinational company and we usually need to convert our currencies and so on. But this is basically an overall structure of a small application that I would have, where you have maybe like 1 or 2, maximum 3 developers working on the application, and it would be a cool way to work on it. For a mid-size example, we have a different structure. So let's go into the source folder, and here you're gonna see that the structure looks a bit different. We have some new folders, but we are also missing some other folders. So one of the additions is obviously features folder, layout folder, and pages folder, and store, which is a replacement for our context folder. So let's start with the components, and you're gonna see that everything that was in a shared folder in our small example is now here, and components are no longer treated as pages for our routes. So button can be reused in some other place, and I'm going to show you where. If you look into the features, you're going to see that we have components such as comments, payment selection, recommendation, and so on. And of course, these features can comprise of different other components, but features are going to use other components that we had in the first folder just above. For example, it can use a button in many of these features, so it's going to act like a parent to our components folder. But here we also have pages, and pages are the one that we already saw before, although now they live in their separate folder and are going to be referenced from the routes, but they're also going to be parents for our features. So for example, recommendations can be inside the home and product description. Here we also have layout, and as you can see, the header.tsx is no longer in components as it was before, but now since it's more of a layout component, it's going to live inside the layout folder. And how you can use all these all together, you may ask? Well, React render props. So you can use features inside layouts and use React render props to pass them around, and you can use React render props again with layout to pass them into pages. As simple as that, your app is going to be very reusable and it's going to be fun to develop. Inside pages, as you already saw, these are pretty much the same things that we had. Hooks, again, very similar. And we have services, but now we have more nesting, such as API folder. Here, you probably would have more files, such as for an interceptor. You could have some shared services and UI services that are all brought together. And you could also have other folders, such as utils, which is pretty much could stay the same, but could also be divided into different parts. But we'll also have store instead of the context now, because I think for mid-size applications, you could use Redux, but again, it's up to you. And I would split the Redux parts based on features, although you can also split them based on pages. So it's very up to you whether you want to use it or not. But this is the overall picture of a mid-size application. Let's say that would comprise of around 8 people, maybe maximum 10 developers that could work together on different pages and different features. Obviously, pages would act as a wrapper for different features, so you would mostly collaborate between features because they're reusable, but each team within the company would focus on a specific page, in my opinion. Now let's go to large architecture, and this is where it gets more interesting. So inside the large architecture, so far it looks very similar, but let's go inside the source folder, and now we have something very flat looking because we have only one folder here called modules. And inside modules, we have different types of modules such as home, login, product description, and shared. This looks very similar because turns out our pages are now replaced by a module. And inside every module, you're gonna have pretty much the same structure that you had before. So every module is gonna have different components, features, hooks, layout, services, and so on, and kind of an entry file called index.tsx that is gonna be reused or referenced inside the routes. So these are gonna act like pages, and as you can see, we no longer have pages here. Well, what is the benefit here? Let's say our large application consists of many parts and our company is big. So let's say 50 or 60 people are working on this one application, and now every team, let's say team comprising of 15 developers or 10 developers, can focus on one specific module. Of course, the components are again pretty much similar as in the mid-size, but now people who are working on a specific page are not necessarily interfering with people who are working on a different page. For example, login and home are not really interfering with each other, but they can still share the code from this shared folder. So this is very cool because shared folder is going to have pretty much the same design as the rest of the modules. If you have
to my full complete course on the new version of React Router and the new version of React Router version 7. In this video, I'll explain to you guys how React Router is now being used as a framework instead of a library, and show you how it can be used to build powerful data-driven React applications. We'll start with the basics, installing, setting up routes, and move through key features like data loading, server-side rendering, form actions, and more. By the end, you'll be able to see how React Router streamline workflows. By the end, you'll be able to see how React Router streamlines workflows, improving your user experience and simplifying complex tasks, all in one cohesive system. Before we get into the video, if we could leave a like and subscribe, this will tell YouTube that you want to watch more of my videos, which would really help the channel. So if you want to support the channel, that's a great way to do so. So without further ado, let's get into the video. Okay everyone, let's get started. The first section of this tutorial is obviously how are we going to generate an application using the new React Router framework. Well, you can use a template if you want to, but we're going to start everything from an empty application, not using any templates. We're just going to run the command npx create set it to be at the latest version. And I'm just gonna put a dot here to represent that I want to create this project inside of this folder that I'm in, and I'm gonna press enter. You're gonna see it's gonna ask us a couple questions. It's gonna use the default template. I said we weren't gonna use templates, but I kind of meant like templates with already some stuff other than the default use template. It's gonna ask this project inside of this folder that I'm in, and I'm gonna press enter. You're gonna see it's gonna ask us a couple questions. It's gonna use the default template. I said we weren't gonna use templates, but I kind of meant like templates with already some stuff other than the default one. It's gonna ask us if we wanna initialize a new Git repository. I'm gonna press yes, install dependencies. I'm gonna press yes, and then it's going to generate the project for us. Perfect. Now we can do npm run dev, and you guys will be able to see the project appearing. I have here this browser, and we should see that it should be running on localhost 5173, and this is the boilerplate app that appears. Now that we have installed it, let's go into the second section, which is explaining the basic structure of the React Router version 7 application. So you see there's a lot of files here that are very similar to if you were using any other framework. React Router version 7 is created using Vite. In this case, as you can see over here, we have our Vite config with all of the necessary plugins. It also generates the application using Tailwind CSS, and uh, I guess you can change that if you don't want to use Tailwind, but I do recommend using it. We also have this React Router config.ts, which will be used for you to, as the name explains, configure anything related to your React Router experience, but we're not going to really be touching this. Then there's a bunch of Docker files. Could help you if you are looking to deploy your app using Docker. The templates come with 3 different Docker files, which are optimized for different package managers. So there's a Docker file for npm, there's one for bun, and there's one for pnpm. So if you want to build using those Docker files, it's really easy to do so. And it also has support for, I believe, all of the different platforms. So you could use, you could deploy it to, I don't know, an ACS on AWS. You could deploy it to a DigitalOcean or Google Cloud Platform, whatever you want. And it has this file all with remix. Going to how your actual HTML structure is going to look like. So there's obviously metadata, there's different links you're going to have, scripts, all you're going to have. There's an error boundary for dealing with any possible errors that you might have in your app, such as running to a page that doesn't exist, and it auto generates that for you. But then also there's the app component over here, which it returns an outlet. And an outlet by default is just a component placeholder for any component that is going to represent the different pages in your application, so the different routes. So if this route outlet over here, if I were to wrap this around with a div, right, and I were to put a little p tag here that says hey, that means that no matter which route you're in, this hey is going to display, because the route component, the component that is displayed depending on the route, is the one rendered on this outlet component. So if I were to go to, not this, if I were to go to, for example, /Pedro, this isn't a route. Actually, this won't be a good example because there's no route. But you'll see as we go on that this should show up. So you could put, for example, a navbar here if you wanted to, but there's other ways to do this as well. So for now, we'll just keep this as an outlet and leave it like it was before. But this is the basic of the root.tsx file. Is where the root of your app is and where the entry point of your application is. Now we get to the, so So this welcome here, ignore this. This is just a component that comes with a boilerplate. We could technically delete this if we wanted to. And that's exactly what I'm going to do, actually. I'm just going to delete this. It's going to break our app for a second, but it will help us. I'll just actually delete this from here. So delete the only part of the app that calls it, and let's just return nothing. Actually, let's return hey. So what I think I should explain to you guys first is how does routing work on this framework. So routing works in a kind of different way from what you might be used to. In React Router, the routing is configured inside of this file over here called routes.ts. This file is only meant to be used to define the pattern of how your routing system is actually going to work. So you see, we have this export default, and it has an array with only one item inside of it. This item is defined function that route. We have the about. So for example, API has some sort of param in it. All I have to do is just add the param inside of here. Let's call it, for example, post ID. Now, this is standard on multiple other routing libraries, but what we need to do now is in our post.tsx, we have to load this param into our component. Now, if you're familiar with Remix, because remember, React Router version 7 is based on every component, the post component, because we'll get to that point later on. Now, how do I create nested routes, which is the next, change it to that.
हाँ जी, कैसे हैं आप सभी? उम्मीद करता हूँ अच्छे ही होंगे। स्वागत है आपका चाय और कोड के अंदर। चाय साथ में चलती रहेगी। एक बड़ी इंटरेस्टिंग बात दिमाग में आई थी कि अक्सर YouTube पे और बहुत सारे लोग इस तरह के ट्यूटोरियल्स बनाते हैं कि Amazon का क्लोन बना दिया, Zomato का क्लोन बना दिया, या फिर किसी और का ट्विटर का क्लोन बना दिया। और अक्सर, हाँ जी, अक्सर उसके अंदर क्या होता है, सिर्फ और सिर्फ UI क्लोन। हाँ जी, जैसी दिखती है ना वैसे। हमारे पास एक लॉगिन पेज होगा, हमारे पास एक प्रोडक्ट का लिस्टिंग पेज होगा, देखो बन गया अमेजोन का क्लोन। और फिर कहते हैं सर अमेजोन क्लोन तो बहुत हो गया, अभी हर कोई बना रहा है। अरे नहीं, एक्चुअली में अगर अमेजोन क्लोन अभी भी बनाने बैठोगे तो सबसे दी बेस्ट प्रोजेक्ट है। लेकिन अक्सर उन प्रोजेक्ट्स में हमने क्या करा है, सिर्फ यूआई क्लोन्स बनाए हैं, कोई एपीआई तक हैंडल नहीं करी। अगर एपीआई भी हैंडल करी होती तो मैं भी तब भी समझ लेता कि अच्छा आपने थोड़ी मेहनत तो करी है। लेकिन उन यूआई प्रोजेक्ट्स के अंदर देखिए खराबी कोई नहीं है, लेकिन एक्चुअली में वो तब अच्छे हैं जब आप अपना यूआई वहाँ पे शोकेस करना चाह रहे हैं, टेलविंड के बारे में बताना चाह रहे हैं, या कोई और लाइब्रेरी फ्रेमवर्क जो आपने यूज़ करी उसके बारे में आप शोकेस करना चाह रहे हैं। अगर रिएक्ट सीखनी है तो रिएक्ट के जैसे प्रोजेक्ट्स होने चाहिए, ना कि ऐसे प्रोजेक्ट जो कि यूआई पे ज़्यादा फोकस करें। तो हाँ जी, यूआई के अंदर हम भी ज़्यादा फोकस नहीं करेंगे, इस प्रोजेक्ट के अंदर भी नहीं करेंगे। हाँ जी, प्रोजेक्ट है, इस वीडियो में भी एक प्रोजेक्ट है और पूरा वीडियो प्रोजेक्ट बनाने में ही जाएगा। लेकिन हमारा इतना सा भी टाइम वेस्ट नहीं होगा CSS की क्लासेस लिखने में। देखिए CSS की क्लासेस लिख के मैं इस सीरीज़ को और 3 घंटे और बड़ा कर सकता हूँ, लेकिन फ़ायदा क्या उस बात का, क्योंकि यहाँ पे सिर्फ वॉच आवर्स बढ़ाने तो आए नहीं है, एक्चुअल वैल्यू देने आए हैं, तो उसके लिए ये वीडियो लगेगा। तो अच्छा, अब इस वीडियो के अंदर बनाने क्या वाले हैं? हाँ जी, बड़ा अच्छा क्वेश्चन है ये तो। अच्छा, सबसे पहले हम जब भी आगे जाते हैं तो ऑब्वियसली बात है टारगेट लेते हैं। पिछला वाला टारगेट आपने बहुत ही अच्छे से और फटाक से कंप्लीट कर दिया था। इस वीडियो का टारगेट है मात्र 500 कमेंट्स। दैट्स इट, मात्र 500 है। मुझे पता है आप एक ही दिन में कंप्लीट कर दोगे, और प्लीज़ फटाफट से वीडियो को शेयर कीजिएगा। ये वीडियो ना अपने आप में एक क्रैश कोर्स है रिएक्ट राउटर का, उसके बारे में डिटेल में चर्चा करेंगे। पहले ये तो देख ले बनाने क्या वाले हैं। तो ये हमारा वेब पेज है और ये हमारी एप्लीकेशन है जो हम बनाने वाले हैं। अब ऑब्वियसली बात है, आप कहेंगे तो बड़ी सुंदर दिख रही है। अरे सुंदरता पे आपको ध्यान ही नहीं देना है, फंक्शनैलिटी पे ध्यान देना है। इमेज ही तो है और यहाँ पे एक टेक्स्ट ही तो है, आप जो चाहे चेंज कर सकते हैं। तो जब हम CSS या टेलविंड की बात करेंगे तब मैं आपको बताऊंगा कि
say you want to build a web page where the home page, the about page, and the contact page all share the same header, which can typically be a navbar. So all of the 3 pages you have are consisting of a header and some component, a header, a component, and a header and a component. So it's basically header plus some blob, some red stuff, header plus red stuff, header plus red stuff. So how can you simplify it into a template, you may ask? This is how you can simplify it into a template. Header plus a blob, a red blob. So here in React Router, we are going to call that blob an outlet component. Everything you supply into the outlet component, whether it be home component, about component, or the contact component, is going to be rendered after the header. And this whole template, we will call it layout component. So that is essentially how React Router layout and React Router outlet works. Now, let's look at a working example together. Here, we have an app.jsx as usual, and I've created 2 folders, Components folder and Pages folder. Under Components folder, I have a header.jsx, I have a layout.jsx, and under the Pages folder, I have About page, Contact page, and the Home page, just like I've depicted in the drawing. In all of these pages, I've just written a very simple description about the page, About page, Contact page, and Home page. Let's shift our attention to the components. In here, let's first look at header. In header, I'm just going to say header goes here. In the layout component, first of all, we have 2 things to import. The first thing we import is the outlet from React DOM. And the second thing we want to import will be, you guessed it, it's the header component. Because as you saw in my drawing here, in the layout component, there are 2 parts. One is the header part and one is the outlet part. So we need to import 2 things. So that's what we're going to do now. Now we have safely imported the outlet function, outlet component, and the header component. Now, what is the order of the 2 things? The first component is going to be the header, and the second component is going to be outlet, just as this picture shows, right? And here is the completed layout JSX for you. And let's go to the app.jsx. In here, first of all, you want to import the necessary library and the functions from React Router. So the first one will be browser router, routes, and route from React Router. And then, next thing you want to do is to import all of the components that you're going to use, which includes the layout and 3 of the pages. So the reason why we're not importing header is because, as you remember, header is already in layout. So basically, we're going to import 4 components only. So let's start with layout. And we're going to import home. Next, we're going to import the about page. And then lastly, we're going to import the contact page. Okay, we're ready. Let's first set up our browser router. if you have seen my previous video, I have explained in details how to set this up. So if you're not familiar with it, please check that video. So this is just a template here. Now let's focus our attention on root. This is where we're going to put our layout component, our home page, our about page, and our contact page components in. The way we're going to organize these 4 components will be as follows. As you can see, the layout is going to be the parent component, which is holding all the pages, home, about, and contacts. The way home, about, and contact will be rendered is going to be according to how the layout was set up. In layout, we have a component called outlet, and outlet is like a placeholder that allows us to dynamically render whatever we supply to it, whatever the child components supply to the parent component. So this is how we'll have a home page with a header, a about page with the same header, and a contact page with the same header. Let's try and code it now. So as I mentioned, layout is going to be the parent component. So let's type that out first. But this is no longer a self-closing component, and this component is going to wrap all of the 3 pages. So make sure that your slash is in have an element called layout.
event-driven architecture. And most of us are probably thinking that this is one specific way of designing your microservices in your backend, and it turns out that it's actually not. First of all, it's a bigger concept that includes many smaller concepts related to it. And second of all, I would say most importantly, it includes specific design patterns for designing your microservices within the system that then make up this whole event-driven architecture. In this video, I want to talk about first use cases for event-driven architecture because this isn't essential. There are cases when you don't want to use event-driven architecture, and there are cases where you want to use. It always has pros and cons, so it's important to know them. And then we're gonna dive a bit deeper into different design patterns for event-driven architecture. As you can see here, we're gonna talk about event notification, event carried state transfer, event sourcing, and CQRS. And of course, we're gonna talk about next steps. We're gonna also look into common technology that is used with event-driven architecture, and we're also gonna look at some code, some basic code, and I think this is going to be fun. So if you're ready, let's get started. So as you can see, this is the basic diagram for an event-driven architecture. First thing that I want you to understand, this is different from a traditional flow of traditional way of microservices querying. So one microservice, let's say this one, querying another microservice to fetch some data. As soon as the data is fetched here, this microservice can then proceed querying or sending the data to the database, maybe to another service. This is a bit different with event-driven architecture. The event-driven architecture is literally the embodiment of the pattern called publish-subscribe pattern, where you have a publisher. So one service is going to act as a publisher, and it can have one or more subscribers that are waiting for the
Test Chrome dead. This motherfucker closed everything again. No, bird, stop closing my fucking song. Don't mess with my songs. Bro, just play my fucking song, man. Just play my fucking song. Fuck. Why are you closing my song? Did you type something? You don't have to type it here, man. I have told you billions of times. You can't get anything from here. Brother, you have to come and type here, brother. You have to come and type here. Can you do it? Let me update it again. Oh, stop killing my song. Donna Damn. Wow. In the job, say click on the reload icon and when you first change, so reload. All right, man. Yeah, dude. Yeah, man. Let's go, bro. Apply the jobs. Click on the easy apply. What the fuck? Captcha. Where is captcha? I don't see any captcha. I don't see any captcha, man. What the fuck? Let me stop. I don't have any captcha here. What the fuck are you talking about? Hammer!